And we're going live, it says. Waiting. Yay, hello. Okay. I'm not quite sure how far behind we are because the preview is showing me just sitting down in my seat, which was a little while ago, so I don't know how far out I am. So I click the go live button and maybe you'll see the bit of me preparing beforehand, which would be embarrassing, but never mind. Anyway, hello. This is my second C++ code live stream. Today I'm going to pick up where I left off from the last time. So the story so far. I'd like to do a talk at CPPCon where I compare and contrast different approaches in C++. We know that C++ is a fantastic multi-paradigm language. You can write just regular procedural stuff, imperative style. You can write functional programming style. You can go crazy with object orientism. You can go do compile time. You can do template programming. All of these things are appropriate choices, but they affect the way that your code looks. They affect testability. They affect performance potentially. And they affect maintainability. Compile time is something that I care about a lot. So I came up with this idea of doing a simple-ish program several ways, and to sort of then use that as a sort of slightly scientific. I mean, it's always going to be subjective, of course, but some kind of subjective measure of whether or not a particular style of programming gives particular benefits. Now, of course, everyone's got their own opinions, and I'm strongly in this more like C with classes camp, maybe with a bit of OO. But my hope is that we'll find something interesting by doing it, by doing this kind of experiment. So obviously I needed something which was non-trivial in order to show up some of the more interesting things, decisions and trade-offs that one has to make in C++, but also not so complicated that I couldn't write it multiple times. So yeah, testability there. So one of the things has just been asked in the chat is, is it possible to test a const.expr only program? Yes, it just doesn't compile. Your tests will fail to compile if the code is wrong, which is kind of an interesting thing. I'm not sure I like it, and I'm aware of any libraries that have like useful error messages, because if your const.expr program fails to compile, it just says, yeah, this thing doesn't work, and you're like, well, why is that? Your static assert fails. You're like, you don't have the nice output of like, was expecting foo but got bar. Foo and bar again, forget it. Anyway, when I left off last time, did I explain? No, I'm writing a path tracer. So a path tracer is, again, just any old project, really. A simple enough project that I've written before, and I could hopefully bang out pretty quickly, and therefore bang out multiple times. A path tracer is a generalized form of ray tracing. I'm sure that somebody who knows a lot more about how rendering works will correct me on this, but this is my understanding. Whereas a ray tracer, you fire a ray for every camera. You sort of trace a ray from the camera through every pixel in the screen and just see what it hits, and then see if that point that you hit was illuminated by a light source. With path tracing, you fire a ray and see what it hits, and then you fire rays from where it hits until eventually maybe you hit a light source, but maybe you don't, and then you sum that over and over and over and over again, and eventually you end up with a scene that looks a little bit more realistic than a ray tracer, because you get a lot of indirect lighting, which is one of the cool things. I'm a bit of a geek about that kind of stuff. So this is what I'm writing, and I've written one before in a couple of languages, and I used this over here on the right-hand side. This small pt.cpp is, let me actually get the website up. I realize I don't have a web browser over on this side. There we go, small pt. So this is, Kevin Beeson wrote a blog post, which I don't know where the blog post is. You can go and grab it. Oh, there it is. There's the blog post. And it's, 99 lines of C++, and it's about as horrible as you'd imagine 99 lines of C++ to get a whole image with multi-threading and everything with, OpenMP. And that's great, and it shows you how relatively straightforward and simple this can be. So that's what I've based this on, although I've only really looked at it from time to time. I also was looking, if you remember last time, at my Rust implementation of this, and I was horrified by how dreadful the code was, so we've kind of drawn a veil over that. At the end of last session, we got a purple sphere, woohoo, rendered using a completely unrealistic lighting method, and it's not even using lighting. There's no lighting is built into this at all. It's just literally, hey, if I hit a sphere, then pick a color so that sort of to do with the whether or not we hit the sphere dead on or to the side. That is obviously not great, and there were a lot of like to-dos in the code. So since then, I have extracted the rendering method. So this rendering method's job is just to fire a ray for every single pixel and do the lighting calculation. Now that is pretty independent of the way that we store the scene, and I wanted to make the scene pluggable so that I could replace the scene object with a more functional version or a dynamically loaded from disk version or whatever. This is very much me sketching still, so bear with me on that. But at least for now, I've extracted the rendering method doesn't care what kind of scene it gets as long as the scene provides a certain amount of functionality. And likewise, the output buffer is just like an array in this instance. So if the output buffer could be made const expr, I could probably make most of this const expr, which is kind of interesting. Where it falls down is where I need to call tangents and normalization functions and things like that. Now you notice that this normalized here is saying const expr, but there's a horrible hack that I have in the library that I added since. But we'll just quickly walk through what's happening in this rendering routine so far. There was definitely some horrible, nasty to-dos and some magic constants that were in the last version. And I have sat down with a piece of paper and worked out where all those magic numbers came from. And now I have drawn myself an ASCII art picture to explain what's going on here. So I feel slightly more like this is an appropriate piece of code now. I don't feel actually sick to the pit of my stomach for writing the code. So all of these values here now are based off of a 50-degree field of view Y. And then the aspect ratio determines how far the field of view is to the X. Yeah, I've thought about that. There is actually some, so that the comment here is write your own trig functions with const expr. And there is already a library that provides most of these things in const expr. But of course, unless I go to C++2a, I can't discriminate between whether I'm evaluating in a const expr context or at runtime. And you only really want to call the trig functions with the const expr versions in at compile time. You don't want to use them generally because they often use like Newton-Raphson approximations. They often are iterative in the way that they're written, and you really want to use the ones that come with the C runtime because it will be just that much faster, and hopefully will compile down to a single instruction in some cases. You know, like the square root instruction. That's kind of useful for square roots, but if I use my own Newton-Raphson method for finding a square root using iteration, then I'd be very surprised if Clang was able to extract from a set of Newton-Raphson approximations the fact that this actually is a square root. I wouldn't put it past the Clang devs. It's the kind of very clever thing that they do, but I'd be very surprised. So anyway, we do some stuff with with camera basis, and we sort of like fire. We get the direction of the camera, we pick an up direction, and then we kind of constrain the left direction and scale it based on the width and the height of the width and the height of the area we're going to fire rays through, and then it becomes a question of going through for all X, for all Y, make a ray that is X units in the direction of the X direction of the camera, Y units in the Y direction of the camera, and Z in the Z direction of the camera. Normalize that so we get like an actual, like a normal, and make a ray that points in that direction, and then say, hey, what does that hit? And then this is the bit we're going to work on today, is that that what are we going to hit currently is it just checks a single sphere. And when we do hit it, all we do is we dot product and raise to and square a vector and with the normal at that point on the sphere. We dot product it with the ray normal and square it and then color it magenta. So I'm just going to build that to make sure everything actually runs. Excellent, hooray! And this is all in debug still, thankfully. I think last time as well, if you remember, we started off with some like ASCII art version of this, but we're outputting a PM image, and I was looking at libping actually. We might do that. So let's go to pt and then find -name image.ppm. Yeah, okay, so the image gets dumped in the current working directory for now, and we can run EOG on that, and behold the beautiful purple sphere or magenta sphere. Yes, Andres is making comments about const expr. I agree completely. So if we just take a quick look at my math library, which I've decided to write my own, just purely to have like the level of control where I can opt in or out of these things. I am not actually a fan of this kind of thing. So like here, the length squared, I dot product the vector with itself to get x squared plus y squared plus z squared, and then I add them together. So we've got x squared plus y squared plus z squared, and then obviously that gives me the length squared. And the reason the length squared is important is it saves me, if I can get away without having to square root it, it saves me from calling just a square root function. And yeah, like here we got const expr double, length squared, const no except. How much noise is there when you're writing this? So this definitely has a -1 to me in terms of readability. But I do like I do like to experiment with it. I know that Jason Turner has a big thing about, you know, no except and const expr. So both of these things are kind of interesting to me. You know, inside my head, I'm like, well, if I got rid of the word const expr here and I got rid of the word no except here, for all reasonable inputs that I can think of, where the compiler can't ahead of time determine the values of x, y, and z at compile time, this will yield the right code. And even if the compiler can determine the things, the x, the y, and the z, it almost certainly will use constant propagation and optimize it the same way it would do for our const expr. I just won't guarantee that. I can't, you know, use this to then bound an array or something like that. So I'm just going to catch up on the comments here. Anything that's set in arrays is doing ray tracing. Path tracing is also yes. So Michael brings up some points about that path tracing. I'm very relaxed with my my terminology here, mainly because the way that I use these phrases is how I learnt it like 15, 20 years ago in the games industry. So I've got a video on Wolfenstein where a lot of people have mentioned that my commentary on like a path a ray caster versus a ray tracer, my terminology is wrong, and maybe that's right. It almost certainly is, but certainly when I was around in like the late 90s, when we were talking about ray casting engines, we meant Wolfenstein and Doom style engines. Ray tracing methods are used for... Yeah, I don't know if that's ray casting. That's the thing that I've been told in many corrections in my videos, is that like anything that fires a ray through a scene is ray casting. So like even like the collision detection that I would do for like gunshots in SWAT would be technically a ray casting engine for collision detection, which is kind of true. Anyway, let's not get bogged down in terminology, as long as we know what I'm getting at here. So there's my math library, and as I say, I don't necessarily love the fact that I've got const expr double, const no except. But we're going to give it a go and see how it comes out, and that's sort of partly the reason for doing it this way. Now, here's my const expr square root, for example. In order to make my square root function const expr, I have cheated completely. And I've tricked out the compiler. So if we're constant evaluated, it returns 0, which obviously is not true. But 0 is const expr-able, right? It's a constant, whereas square root is not. Now the compiler seems to be happy enough that even though this thing is always false, this whole function is in principle const expr, which means that I can call it from const expr contexts. Sorry, I can call it from functions that are marked const expr. Obviously, if I ever tried to use it in a const expr context, it would immediately give me a compiler error. But I like to tag it just so that when I work out a way of having this const expr evaluation stuff in, I don't have to change all my code everywhere. That's the thought. Okay, I have been talking a lot. All right, so we've seen main down here. Main just has this static scene. So here are the two implementations of the classes, and I'm required to put a space there by my own coding convention. The scene has a single method called intersect, and intersect is calling just the single sphere intersect. It returns like a hit record telling me what it hit and a little bit of information about it, which we're going to have to augment in a second. And we've got this array output, which just has a vector, and this is where a lot of the non-const expr thing goes from. This non-const expr comes from the fact that std vector is not const expr, so I can't... I can't rely on this pixel at and plot function being const expr. In fact, I can't even construct an array output in a const expr context. So I kind of, at that point, I flipped the table and said, let's forget the const expr type thing for now, and just get on with my life of trying to get something interesting rendered. Okay, so we've got two things I'd like to work on today, and maybe a third if we get either completely stuck and just need to go down a route where I can get something that I know done. And those three things are, I would like to make the scene more complicated, just using this static scene. So I'd like to actually have like 2 spheres. As part of that, as soon as I have 2 spheres, I'm going to have a way of discriminating, excuse me, which sphere I've hit and with what kind of material qualities does that particular sphere have. That will then give us a new color, a new image that has colors in it. Once we've done that, we will actually work on the path tracing part of this. We'll add emissivity, which is like how bright intrinsically is an object or a material at a particular point, which gives us lights. When do you ran slow? Okay. Interesting, yes. I probably won't be using DRAN. That's on the right-hand side here. That's for... so someone's made a comment about DRAN being super slow. It's interesting to know, actually. I don't think I would use DRAND or ERAND or any of those things. I would probably end up using the C++ new things, which may or may not be worse than, you know, the Mersenne twisters that are available. We can certainly experiment with that. So yeah, anyway, the two things are scene, material, and real actual rendering. And then if we get stuck, or if we just want to do something interesting, I'd like to use Conan to bring in either Google Benchmark to do these kind of benchmarking tests that we're talking about here, like which random number generator should I use, or libpng, so that I'm actually outputting a ping and not a horrible ppm, which is fine. I mean, it works, so I shouldn't really change it, but there we are. So let's think a little bit. So at the moment we've got these building blocks of geometric primitives like spheres, and I'm anticipating that these probably won't change, like between the various implementations, unless I fancy rewriting a math library each time for each like version of this. Then I don't think I'll do that. So it's designed to be as simplistic as possible. Now, it seems to me like... here we are, we're showing all the things I've got open. Let's go back to main, there. And a cat's just come back in. So it seems to me that there should be a notion of an object in the world in some way. So we're going to sketch this completely and just see where it goes. Just magenta and just planet, says Andres. Yeah. So how in depth do I plan to go with materials, albedo, emissivity, and then what, roughness, specular and stuff, or just colors? Well, yeah, there's got to be a BRDF. So BRDF characterizes it's the bidirectional reflectivity distribution function, or a BSDF, which is the scattering. I forget now. So I'm going to look at picking up some of those bits and pieces. There's some of that sort of skeletally formed in the small point version here. I don't know myself how fast that's going to, how that's going to go down yet. But at the very least, I want to have. Oh, sorry, cat. Put my books where the cat likes to sit. I don't know how far down that route I'm going to go yet. I'm probably going to, just at the very least, support diffuse and specular like small point does, but probably parametrically so. So lights are not a thing in path tracing. One doesn't need to have a light. There isn't really a thing that is the same as a light, because every object itself could be a light, right? Every object has some way of, if it has a non-zero emissivity, an object is a light. So if you want to have a light in a traditional path tracing scene, obviously we can add in like fake actual like ray traced lights as well. But one would just make a sphere somewhere and then say, hey, this has an emissivity of like 100% bright white. And then as the rays are bouncing around inside the scene, the ones that end up on that light get energized with light and so forth. The whole path is lit. And so you just do enough of those samples and eventually you get like a really nice scene. We hope. We see. There are a whole bunch of optimizations we can add on afterwards, which are more algorithmic optimizations of like, well, I know some things in the scene are actually lights and therefore I will trace to them specifically and so on, but I don't want to get that far just yet. Right, so let's think about this. We've got a sphere, and so a sphere by itself is not really enough. We need some kind of object representation. So I'm just literally going to go up here and say struct object. That object. And my computer is lagging, unfortunately, which is making this a bit more annoying. So I think I'm probably going to start down an OO style representation. first and foremost. So let's make this, actually, we're going to call this class intersectable or something like that. Does that know? Right, we're just going to call it class Bob for now, because again, we just don't want to get caught up in what this is really called. We're going to make this virtual Bob equals default. So, and what we need then is some kind of hit record, which, so the sphere itself has this hit, where are we, optional hit, and this hit has a distance, a position, and a normal. Now that hit doesn't carry any further information about the material, so it kind of needs to be a tuple of material and hit that we need to return from our like object intersection methodology. Primitive's a nice name there, but it doesn't necessarily need to be a primitive, right? You know, a primitive in this instance could be some, you know, really complicated, highly tessellated. It could be the Stanford bunny, which is a primitive, can't be divided further, I suppose you could argue. But we'll come back to that. Thank you. Yeah, exactly, Luca. You know that this is going to stick. But I'm going to make a placeholder material. Well, let's make it a struct, because I've got a feeling this is just going to be something else going on. It's going to have a whole bunch of things in it that we're just going to be read-only for now. So we're just going to stick that there. We're going to need, obviously, a vec. Oh, one of the interesting things, actually, I need to come back to is that towards the end of last time when we were talking about this, I think I convinced myself that the vec3 should probably be 2 classes, or if not more, where I strongly type the underlying data so that we can have normals that are just known to be normal, and we could have, in this instance, I'm going to put like vec3 color here. Obviously, vec3's, so this is like emission, and then vec3 diffuse colors. So these are colors, right? And there's no way you can tell from vec3 that that's a color or not, only by convention and kind of knowledge that it's a color. So we've got a material there, and then we want to say, we want to have a virtual method on here, stirred optional. Well, actually, let's using something in here, because I was about to make something complicated. So we're going to say using stirred optional of stirred pair of material and hit. See, this is annoying, isn't it? Intersection record. Terrible name. Again, more terrible names. I like primitive, you know. I'm going to go with primitive. And then, although this is sort of in the top level directory right now, I'm going to bring up the project, and I'm going to start this in the 00 version. So I'm going to actually make a new. So let's just make a new file in here. New file, and this is going to be cmake lists.txt, and we're going to shamelessly crib from the other one, and this is going to be 00, and it currently has nothing at all. Add targeting 00 ... which is not right, but I'm going with it. Okay, and then obviously we're going to have to include that. Add subdirectory 00. All right, so I am going to bust out. Hello, no sources. I know there's no sources. It's fine. We're going to give it one in a second. So material strikes me as that's going to be shared amongst everything. So I'm going to currently leave that where it is. Although, actually, no, I would need to extract it. That's interesting. So let's make yet another directory. Let's make a directory of. It's not really part of the math library in any meaningful way, is it? I am just going to put it at the top level for now. So at the very top level, new. Oh no, that's going to be interesting, because 00 is going to need it. Oh, the project layout. Project layout's a pain, isn't it? Okay, for now, to save any kind of further thoughts about it, I'm going to make material dot h. Don't add to targets, because you don't know Ugh, horrible. Get rid of that. Pragma once. That. Include math vec3.h. And now we can say that this has material.h, and we can also say target link libraries 00 with math. All right, does that work? Let's reload CMake project now because the IDE is upset that I did something behind its back. Okay, good. And you should now notice, there you go, it's part of the project. Excellent. So that's one thing done there. Back to main.cpp. Let's go and get this primitive. Okay, and we're going to go into 00, new C++ class, and we are going to add to targets now because now it knows about this 00. I'm going to say primitive, and yeah, that's all great. Paste. And we need, what do we need? We need to have optional. We need to have pair. Is pair in a header? It's utility, isn't it, I think? And I'll probably give that a name in a second. I don't really like pairs generally. We do want material, so let's include material. And this is not the right place for this material class. It's becoming more and more obvious to me. And we're then going to include math hit.h. See, I'm in two minds as to whether a hit should really carry the material directly. I don't think it should. I feel that like we can do hit testing with geometric primitives without like sullying them with any kind of idea about what materials are associated with them, because like an intersection with a sphere is an intersection with a sphere, and that's all you need to know, right? We may end up with using the to template specialization. What? Oh, because I've got this the wrong way around, because I can't program in C++. There we go. All right. So here's a primitive, and we're going to say virtual intersection record, intersect, and we need to give it a const ray amp ray. Yes, math ray.h. But the IDE wants to put chevrons around it, angle brackets, and not less than and greater than, and I don't like that. Const ray equals 0. Brilliant. Okay, now there's a number of things that's probably wrong with this. I may need to give it some kind of hint here to prevent an expensive intersection record if it's already far enough. If the current intersection that we're testing is actually nearer than it, we could probably bound the distance we have to search for array. But right now, I'm just going to throw it all in there and see what happens. You may notice this is a common theme. It's like throw stuff at the wall, see what sticks, and come back round to it. Okay, so now we're going to go back over to our main, wherever that's hiding. And I'm not even going to write any tests for this stuff yet because we just need to get something out. And we're going to say static scene, and that static scene we're going to include up here. Oh, I see this is already using the less than things. Well, we'll stick with it for primitive.h. All right. And this auto intersect is now actually going to return a... Well, let's rephrase this. Let's rephrase everything in terms of that new primitive. So we're going to say struct sphere primitive, and we're going to have sphere. I can't talk. Material. It's struct just while I sketch, and then we obviously need to implement intersect, thank you, and we're going to do that. So we're going to, instead of sphere.intersect ray, we're going to return if, right, so auto hit equals sphere.intersect ray. So first of all, we use the geometric primitive to say, did we hit anything? If we didn't hit anything, then we can return, no, we didn't hit anything. Otherwise, we're now going to return the intersection record, which is the, as we know, now you see this is the problem with it being a pair, material, and then hit. That's the wrong way around, isn't it? Do you not think that the most important thing that is going to be the hit? Hit and material. Better? I think so. Hey, Neil. Are you a Neil or a Nile? I'm sorry. I will say Neil until I hear other words. But I apologise if I've already mispronounced it. Well, I will have, by definition, I've mispronounced it at least once. So, if we did get an intersection, we're going to return the hit and then our material. Lovely. Wunderbar. And you're complaining because intersection record is an optional pair of hit and material. Really? Do we have to spell this out? So, comment here is a good way of min and max parameter defines a section along the ray with which you're looking for intersection. That's absolutely a good point. I think I will either end up doing that, or I might end up specializing ray itself to be like a line segment that can just be infinitely long as well. That works too. So either of those things could work well. Intersection record, and you are complaining because, oh, does it really not allow me to do that? Oh, because I'm gonna have to do make pair, aren't I? Stood make pair of that. There. Now you should be able to work out that that's make pair of hit and material as an Why can't you convert that pair to an optional to function return type? So we're trying to make an optional of hit and material, and we can't turn a hit and material. What have I done wrong there? Okay, Niall, excellent. Thank you. Yeah, so Michael's also made great points about like like we can easily do things like optimize the nearest point of approach and just say, hey, if you're never going to even hit the nearest point of approach, then we don't even have to do any further intersection. But right now, I'm just having a problem where I can't construct this. Can I? What if I explicitly do that? I didn't think I had to. That smells badly. An intersection record, and it says it's an optional of a pair of hit and material, and we've got a hit and a material. Hit is definitely a hit. I'm going to see what the compiler says. It says the same thing as the IDE, unsurprisingly. Okay, no matching function called to optional of a pair of hit and material. A pair of an... okay, so that hit is an option already, and we know that it's true, so we need to do that, which means that now we can get rid of probably that bit there. Is that working? Yeah, I'm a fool. There we go. So we've now got a sphere primitive that at least compiles. So the next step now is to plug this in as a sphere primitive sphere and give it all the relevant constructor parameters. I can't type. Oh, that needs to be a sphere, and that hopefully with a material. I think I can just default constructor material for now. Again, placeholder all the way. And now this will error because it's expecting a reference to must be called. Why? What are you talking about? Sphere. So I'm just going to call this scene in anticipation of what's going to happen next. So someone's saying it's interesting. Yeah, Arubrus, the problem there, that's a good point, actually. It should do. I will do that. That's what I initially did, but I forgot that I needed to do star of hit, because that hit itself was an optional. See, actually, it's complaining again. See, no matching AK optional stood pair. So I don't know why that's unhappy. I don't think it likes doing it, but I'm not going to argue too much more with it. So what the question here is, what is the purpose of material and ray collisions? Yes, to decide what to do next. Hopefully that will become abundantly obvious in a second, where I'm basically going to replace this hard-coded purple value here with just the diffuse color, and then we're going to run it all, and then we should get our purple planet back, and then we should be able to add a second planet and make it a different color, and then we can move on to the what's it called? the actual like ray casting bit, not the raycasting, the path tracing part of it. That's the hope, but we need to get it compiling first. So scene.intersect is saying reference to non-static method function must be called. I am not sure. I don't think I've seen that error before. Oh, is it just complaining about this? Am I just being silly about how you... am I overly hopeful? Yeah, I don't think I can do this, can I? Let's do this the way that I would otherwise have to do it. Let's just have static scene. Oh, come on, scene. And do scene. Brr, brr, and then reformat the world and see that that works. Oh, too many parens. That might have been the original problem. Turns out I'm not actually very good at this. But it's fun. It's fun exploring. And hopefully we get something pretty to look at the end. No matching... Oh, because there isn't... I haven't written a constructor for that. That's very annoying. Let's apply the IDE constructor. Yes, both of those, please. Yeah, that's what I wanted. See, this is where IDEs are kind of nice. I know you can do this with non-IDEs as well, with all sorts of things, but you are complaining because... Okay, is this discards qualifiers? Because... Oh, intersection is potentially mutable. I don't think that should be. So we've got a problem in our primitive. Working on graphics now and not physics. Right. Yeah, this is never really that physics. I know we're using path tracing, which is meant to be the more physically accurate way of doing it. But right, so intersection should not modify the object that it's intersecting with, which I think is fair and decent. All right. Now we're in a situation where we were using auto before, and the intersection object that comes back to the render function is no longer an optional hit, it's an optional intersection record. And I might even rename those, you know. I think probably it's more... yeah, we'll come back to that. But anyway, so if we have a hit, then we now know that this hit is not the same type that it was before. I am going to use hit. Let's name these things. No, this is already it. I'm already sick of the fact that this pair is not clear. So I'm going to call this darn it. Hit material. It's just a bad name. Everything's a bad name, which is telling me that there's something really not great about this. Hit material. A material. And now I think I am going to get rid of this intersection record. In fact, yeah, okay. The struct becomes the intersection record, and then we just return directly an optional intersection record. That makes more sense to me. I think I prefer that. And the primitive's now no longer a good name. I think it should just be like intersectable or something like that. Okay, so then this needs to be stood optional of that. So we're not hiding the fact that it's optionally. Otherwise, we return... Oh, what was that? Oh, I think that's the post arriving. 1 second. Yes, it was the post arriving and the cat playing with it as it came through the letterbox. Okay. Where were we? So yeah, I was separating that intersection record, and so now we're going to return intersection. Well, I wonder if we can get away with that. I don't think that's going to work again. It would be lovely if it did, but I think I have to name it here. I don't think it's smart enough to go through 2 levels of indirection. Saying it knows it can construct an intersection record from that initializer list, and then from that it can generate an optional of that. So we're going to have to name it there. And there's probably copies and things going on here which we can get rid of, but this is more, again, feeling out the surface of what we're doing. Okay, that seems better to me. So if we got a hit, and okay, we're going to actually call this intersection record, because that's what it is. And then we can sort of say auto amp mat equals intersection record. Come on, intersection record. Oh, come on, IDE. You failed me. Material. So we don't need a mat here anymore. And now this can be mat dot, and it still doesn't unfortunately know what type that is. But in our material we called this diffuse. So we're going to call it diffuse for now. And then we do auto amp hit equals intersection record hit. And then we're going to do hit normal. And that's going to be hit dot normal now because we've already got rid of the thing, the what there. Okay. Let's build. And I didn't want to debug it actually, that's not what I meant, but it doesn't matter because it ran. Now of course we've got the EOG thing somewhere. Yay, we broke it. Okay, I was about to say I should probably change the color so that we could actually see that I had really rewritten the image. So I'm going to make this always on top and then hide it over here where you can't see it over my ugly face up here somewhere, I know, but now we have to work out what's going on. Oh, I know why it's not, because we just default constructed the material, right? And of course it default constructs to black. Hooray! So material, we need to make it emission and diffuse. Now I'm not excited about this either, where we're going to say Vic3F, Vic, what am I, South African? Emission, so that's just, I am going to leave it as 0. You can tell Vic3F is what I used to call this kind of thing. Vec3 at 101. Okay, auto. I don't like that formatting, but I'm down with it enough. Okay, so we're going to rerun that, and luckily we notice the EOG automatically refreshes. Yay, we have our purple ball back, and just to prove that it isn't a fake and it isn't a complete fluke, we're going to go and change this to be 0.5, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. There we go. So we're changing the color slightly, and with like a 4 or 5 second turnaround, which isn't bad, right? It's C++ we're talking about. So there's our really, really simplistic primitive sphere primitive. So how about if we were to do something like this? Scene primitive, which is a primitive, which is I can't, first of all, I can't spell primitive, so I'm gonna have to change it because I keep misspelling it. Secondly, I think as we do this, we're gonna realize that this approach is gonna give us a better name for primitive. 0.2 frames a second, yeah. What if we were to have a vector? Let's make this its own thing. I'm going to put it in OO. New and C++ class, and we're going to call this a scene because this is what it's going to be. And it's a scene primitive, but I don't think we need to encode that in the name. I think that's good enough for now. And I think pretty soon we're going to have to add some namespaces here, or else all hell is going to break loose when I start doing my second and third implementations that almost certainly will have a scene as well of some description. But again, sketching. What do we want? We're going to OO primitive.h, and then we'll say, yo, this scene is a primitive. Public primitive. And as such, we need it to implement the intersect. Wow, thank you, IDE. That's dreadful. Well, we'll live with it. And we want it to... This works pretty well, actually, with the view over there. Am I counting the... I am counting the building time. Yeah, you've got to count the build time. So this is const override. I applaud this. And what we're going to do is we're going to have a hash include vector. We're going to have a std vector of std unique pointers of primitives scene. So obviously, immediately, this is the most naive scene you could ever imagine. We're just going to iterate and find the nearest one. the interface is such that we could potentially build bounding spheres or bounding boxes or any other thing around it. We could use BSPs, we could use any number of quad trees or things to speed this up. But for now, this is what I'm going to do, and we're going to see how this goes. Memory all alone. Let's call these primitives, because that's what they are. Savages, even. Okay. We're going to have void add std uniquer pointer of primitive primitive. Lovely. So we have a scene and we're going to add primitives to it, right? And when you add the primitive, you give up the ownership of the primitive. It's like, I'm done now. You deal with this. Your thing. There are many ways to skin this particular cat. In this instance, I think this is the right way to go about it. The cost of like the allocating memory all over the place is going to be cheap-ish, but it will be an interesting thing. So this maybe probably means it makes me think that having a something someone mentioned in the last time we did all this stuff was having data. Or was it data-oriented programming, data-first programming? Darn it, I can't think what it's called, but. That could be faster, right? Because if one separates one's data into like sphere intersection records here, like have an array of sphere intersection things, you can blast through that a lot faster, certainly for this kind of thing. So Andreas has made a point about typing is 100% of the time, build time is nothing. I don't agree with that myself. Build time is a super important thing for me because my workflow is always like I'm building, I'm typing, I'm building, I'm typing, I'm building, I'm typing, I'm thinking, I'm building, I'm changing. And for tests, I like that. But I appreciate there are many people that have the opposite view, and I totally agree with you. One of my best friends and colleagues to work with, favourite colleagues to work with, is very much that kind of sit down, ponder deeply, and write the code right. And the build time is immaterial for him, except for like the continuous build system, that kind of stuff. All right, let's stop talking about it and start writing it. Stop trying to program and program. So we're going to make the add, and we're going to say, what is this called? Scene? Oh, primitives. Dot in place back std move of primitive. Hurrah. Data oriented design. Yes, I think that's the right one. Why also inherit from primitive when using composition? Well, so Ludo's asked why would I inherit from this. This is interesting because the scene here could be a sub-scene now as well. At least this is like my traditional OO methodology, is that like the calling loop doesn't care what kind of primitive it's going to be rendering. It's just going to render against a single primitive. But that primitive could itself be a hierarchy of other primitives. So I could obviously change that. This scene doesn't have to be a primitive, and it would work exactly as it's written now. But I'm starting with this. It's like maybe we could call it like a primitive group or something like that. So you're absolutely right, though. It's almost daft to do it. Although, in a funny sort of way, we're going to make that a scene, and scene comes from scene.that. Yep. And now the scene is not like that. Scene is just empty, so we can get rid of this constructor. It doesn't. Oh no, the constructor needs to actually populate the blessed scene. So that is our object that we're going to be poking in. We're going to go scene.add. Excuse me, std make unique of sphere primitive, which is also going to have to be extracted pretty soon, right? Of all of that nonsense. Reformat, save me from myself. Why did you not break line there, you annoying formatter? I think we've upset the formatter. Okay, that needs to close with that, and then we're done. Does that make it better? Yes. Except it's still indenting everything. What am I missing? So that is a material vec3. Oh, that closes the material. Let's let's manually bust this out. So we've got a sphere, and the sphere needs a Vec3. That looks right to me. That looks balanced. Then this material is from there to there, and then that closes the sphere primitive. Do we need another one of those? Yes, there we are. Oh golly, hooray! And now the IDE is happy with this. All right, so this isn't going to compile. So Ludo, you're absolutely right. I mean, this is just the way I'm thinking out loud, and you're getting exposed, unfortunately, to the raw thought processes and not anything else. So there we go. So if you've ever seen this error, and this is me kind of doing this on purpose, the undefined reference for vtable for scene, this is a sign that you have forgotten to implement one of the functions inside your project. Now, as it happens, it's also telling us undefined reference to scene intersect. But I have had this before now where I've left out one of the virtual methods, and then you get these bizarre and strange references to vtable for x or vtable for y. Do you not need to delete the sphere? No, the sphere is a parameter to the sphere primitive. So the sphere primitive needs a sphere and a material, and there is the sphere and the material. And you know, this is where I'd love for the automatic formatter to not put them back on separate lines. Okay, so yes, this undefined reference to vtable of something is a clue. So if you've ever wondered why this is the case, what happens is that the compiler needs to emit the vtable somewhere, and it doesn't emit it like every single time it sees a class, because that would cluster up all of the obj files with redundant copies of the vtable, giving both the compiler more work to do and the linker more work to do. But interestingly, the decision the compiler makes is that the very first virtual function that's defined also emits a copy of the vtable. And so because I didn't actually define that particular function, we're missing the vtable as well. So and you can see both the constructor and the destructor require that vtable. It's interesting that the destructor needs it. Not quite sure why. I think maybe the destructor puts in like one of two copies of the vtable. It puts in the copy that points to the scene itself, and then it puts in a copy to one that has like pure virtual function call for that particular type, so that when you're destroying it, you get to the beauty of having a vtable that points to something which says, please don't call any more virtual functions, they won't work. Okay. Yes. Yeah, exactly, Alexander. Sometimes the error is so useless and you look for like 3 hours. Precisely. But it's one of those battle scars that one has. So we are saying undefined reference to scene add. That's because we don't link against that library right now. So why don't we do that? So cmake lists for the main project, and we say, hey, pt3 ways, which is main.cpp, and it depends on math, and it depends on as well, which is the object-oriented version of this. Now, again, namespaces need to come out pretty soon. Hurrah! Now things are looking a bit happier. Unused parameters rate. Oh, I did define the functions. Well, there you go. All right, I was wrong about the problem, although the symptom was similar. It's like telling me that I hadn't defined that particular function. If I really do plan to support for acceleration instructions later, it might be better to provide the contents of the scene in the constructor rather than having an add method, because the add inherently would require to rebuild the data. That is true. What I typically do with this kind of thing, though, is to have like a commit after you've done all that, which is like, this is the point at which the acceleration structures get built. The reason I don't really want to have it as constructor parameters is that ideally I'd read the scene description from like a text file. And so the constructor doesn't know how many things ahead of time it needs to construct. I'm just going to be parsing a text file and go, oh, sphere, space, XYZ, space, Y. Okay, I'll make a sphere object, new sphere, put it into the scene, and so on. So that's my rationale for that anyway. But I appreciate that that's a very clever way of doing it. And that this is also like similar to like the builder pattern. So if you've ever used the builder pattern, and that might be a better way of going about this. So this is really useful feedback, Michael. So thank you. Is to like have a scene builder where you call add, and then when you've finished adding things into your dynamically generated scene builder, you call like I guess, like seal, like I said, or dot finish. And that's the thing that then converts itself into a scene that can't be modified anymore. And at that point, you build all of those acceleration structures. But right now, I'm thinking I won't need acceleration structures. Although, at the back of my mind, I would like to like render the Stanford bunny. And that might be an interesting thing, because the Stanford bunny has like, thousands of triangles. And so a triangle mesh might just be a special case. And their data-oriented design might be better. I mean, obviously, if I nude up a triangle for every single triangle in the Stanford bunny, that also seems daft. So there's going to be some interesting trade-offs to go down the way. Right. It could receive directly the vector of unique pointers. That's true as well. Yes, that is very true. So that's a kind of like the builder pattern. Essentially where you've exposed your innards. So what you're doing there is you're saying like, hey, you have to make a vector of these, even though I may not need a vector, I might store them as a list or whatever. So it's only a way of doing it, and no one would be. I would not be against it, but just instinctively, I prefer the add methodology, because it means I can hide whatever container types I've actually decided to use behind the scenes. It's only used for construction, so it's not a big deal. And yeah, I'm not really planning on doing accelerations right now, although as soon as we get to triangle meshes, that's going to get a lot more different. So we've got we've written we haven't written an intersect function. That's what we're missing, and I keep clicking the wrong button. There we are. So here is our hey, you hit nothing. So if we run this now, we should now compile. Oh, apart from the unused parameter, thank you. So just for the purposes of showing you how useful that warning is, we're gonna comment out the ray. And we get black because nothing ever intersects with the seam. So now we're going to write the code. So for auto amp, we're going to have to use amp here because we're going to iterate over the unique pointers, which is also like a bit of a nasty thing to do, but whatever. Hello. Primitives. So before primitive in primitives, although I've got a reference here, we have to remember this is a reference to the unique pointer, so it looks like a pointer. I'm going to say auto hit equals primitive, come on, primitive, thank you, dot, like a pointer, like I said, intersect ray. If not hit, continue. Right, we might as well say, like, if we didn't hit anything, we might as well move on to the next one. I'm a fan of early, like, skipping rather than indenting and indenting. So the alternative to this would be to say if hit, next thing. So we're also going to need up here some kind of intersection record. I've got to remind myself what's in the hit structure, because I think this has this. So we have a distance inside the hit structure, and that's what we're going to use as our a guide for this. So we're going to take an optional and say this is nearest hit. Just nearest, I think, is good enough from its. You see a dark green sphere right now. Uh-oh. All right, I'm not keeping up with the chat, I'm afraid, so please recall out anything that's particularly worth me if I don't discuss it within like 30 seconds or so. Okay, so if not hit, or... come on now, we need to say... Right, we'll see if we can convert it. So if we have a nearest currently, and the current nearest's hit dot distance is, well, we'll do it this way round. If we have a nearest, which way round do we need to do this? We want to say, when do we skip it? We skip it if we already, like the hit that we currently found. We're going to skip, we're going to ignore that hit if it is further away than the current nearest hit. So if we have a nearest and the hit's distance, hit minus arrow hit dot distance. I think the IDE is confused here, and it's further away than the current nearest hit, then we're going to continue as well. And we're going to sort of see if this won't make sense to combine them in a second. Otherwise, we're going to say nearest is equal to hit. And so hit's a terrible name. So this is intersection. And this nearest here, we're going to call it current nearest. And then we're going to reformat all of the things. And so let's read this through. So we're going to say, hey, do we intersect with anything? If we don't, we're done. Otherwise, if we have something that's currently like the current nearest thing and the distance away is further, then continue. Like, we don't want to do it. I don't like that. This is where I'm actually going to turn that the other way around. Oh, no, if I turn it the other way around, then I have to deal with the fact that if we don't have a current nearest, then, yeah, what happens if I say invert if condition here? Yes, thank you. See, IDE is good. Right, I don't like you. I prefer it on the line, but there you go. Right. So if we don't have a current nearest, or the distance of this current intersection is less than or equal to, well, I think less than makes more sense, don't you? Then we're going to say current nearest is intersection. I prefer that. I think that makes more sense. Right. So let's with our one and only primitive anyway, let's render it and see if we get our purple sphere back. Yay! Okay, so the next thing to do is go to our scene in main and let's add another one of those spheres. So let's make a red and green sphere. Same distance, same thing, but we're going to do it minus 10 units. I have no idea what this is going to look like, but I'm expecting it to be on the left. But if it's on the right, then we know that we've also got the camera the wrong way around. What do you say? Why? Did I kill a bracket there? 1, 1, 0. Are we happy now? Yes, we're happy now. Oh, look at that! Look at that. It even looks mostly right, I would suggest. It's sort of off to the left, so we've got this slight bowing away from us. It's not a straight cut. Now, if we were to like, if I was to make this +5 and -5, we would see a straight line down the middle, I think. So let's just trying to develop some intuition that my camera is the right way up here. Molecule, yay! So now we've got a straight line. That makes me feel better. Let's move this one a little bit in the positive Y direction. Should we see which way positive Y goes? Hooray! Positive Y is in fact the way that I was expecting it to be, but I was too chicken to mention that I thought it should go up. Alright. And now if we were to move this one forward, let's put them both at 0, 0. They're both 15 units wide, and I'm going to make this one 10 units closer to the camera. And just make sure that all works as well. Excellent. So that completely obscures the thingy behind. If I make it smaller, the sphere. I don't know if this is going to make it small enough to see both. Gorgeous. And you can see here like the terrible lack of sampling and just the terrible everything, really. But, you know, we're there. So there's this horrible blackish halo around here because of the way that we're doing the lighting calculation. So let's fix that one next. I like them being side by side. That was quite sweet. So why don't we actually totally separate them and make this one -10, this one +10, make them 50 units away, make them both size 10. Negative radius. Oh no, don't break my code. Alright, maybe I make them like 9.5 units. I want to actually have like a discernible gap between them. Oh, 9.5. Let's not make it an octal 9.5 units. Hurrah! Okay, so we have our two beautiful materials here. So I think that's worth checking in for a start, because we have something that's not dreadful, which I think is a good enough. We're in, what, like an hour and 5 minutes, and something not dreadful has happened. There are many, many questions still open. So we're just going to say staged multi-object scene sketch. Yay, git pull. I think I got everything. Yeah, git push. I guess I should write tests for all this stuff, but at the moment we're still sketching. Okay, so the next thing is, why don't we see if we can get some actual tracing going on here, like actual like second bounce stuff going on, as opposed to just assuming everything is this horrible take the square of the ray direction to the camera thing, which is clearly not right at all. So this is going to require some stealing from small point, at least to start with. So let's not have this always on top for now. Oh golly. So this becomes very, very tricky. So at the moment, this intersection stuff here, we haven't extracted a function. So the real thing here is like this code, this render code here, is meant to be for all pixels do the radiance calculation. Now we need to be able to fire multiple rays on from arbitrary points, and so this whole area of the inside of the loop right now needs to be extracted so that it can recurse. And we don't necessarily have to recurse, actually. We could iterate. There are ways of making it work that way. But I think calling it radiance and extracting it. So let's see. This is going to be very unlikely to work, but I'm going to try extract method here. Declaration above. We're going to call it radiance. And then we're going to... No, see, that's not right. I need X and Y, and I want it to return color. So I'm just going to extract that bit. Vec3 radiance. And it takes a scene, it takes a camera position, it takes a direction. That actually seems to be about right. It's taking a scene by constant reference, it's taking a camera position by constant reference, it's taking a direction by camera... That's wonderful, except this is not camera position, this is just start, and that is direction. And then we're going to add a parameter of type int, which is depth, and we're going to extract it. I love it when the IDE works. It doesn't work very often. Alright, and you're complaining because no matching function called to... reformat. Thank you. It's like it extracted a function, didn't actually reformat it. So why are you complaining? No matching function called to radiance. But I see a matching... Right, well, let's inline it there. Yes, inline it. And then you're complaining because we've got a constant scene, we've got a direction, we've got an int depth. And you've put 0 there. What does the compiler think? Eye of gnome. Oh. Unused parameter depth. Well, that's fine. So depth is designed to eventually decide, like, you know, we've been bouncing rays around forever and we're done now. Through something called Russian roulette. So I'm going to steal currently what the small point implementation does, and then we're going to think about it. Oh, good lord. Oh, this is assuming we've hit. I see already. Yep. All right, so let's ignore that for now. So, and we're going to switch this around and say if not intersection record, return vec3 paren. I'm going to just for now go maybe unused on depth because it is unused. We're not going to do color, we're just going to do return here. And then we can get rid of that, and then we can reformat, and now we've got nice code. And I'm going to put a little space there. Alright, so now we're in this world where we say, hey, we want to make a ray. I might actually pass the ray there. I think probably that makes sense. This is the whole point of start and direction, isn't it? So let's make this const ray and ray. Then we can steal that. And we can make the ray live here. And this becomes campos. And then we put ray in there. And then we say, actually, we might as well just inline that as well. Yes, inline, no, inline, boom. And then wonderful, looking lovely. This needs to be ray dot direction. It's going to go soon anyway. And let's just make sure we are left where we were before. I don't know, how many of you use this kind of approach where you think and you iterate and you type and then you run it again, and you know, like ideally I'd have tests for this. So when I was, if I was doing this in a more traditional situation where I knew ahead of time kind of what I was getting at, then I would have written tests to say assert this, and then I do red-green testing and I extract and move things around. And I definitely like to use the IDE to do some of these things. It doesn't, as I say, it doesn't always work. Const scene amp. Oh, that's interesting. Oh, because it's of type here. Oh, we're gonna have to make this templatized on template type name scene. Well, there's an unfortunate side effect there, right? All right. Now, do we still have? Where's EOG? Yeah, we still have our lovely coloured balls, and now we can start thinking about what parameters we need to pass into this. Now, I'm going to think we're going to need some kind of overarching per pixel random number generator, and the reason it needs to be per pixel, it needs to be seeded so that we get the same answer every single time for every pixel, regardless of how other things move on. Right. Oh, hi, Yubi-san. Good. Everyone has their own approaches to this kind of stuff, and you know, it's always interesting to see other people's thought processes. And certainly, me doing this live makes me think more out loud than I would do if I was just sat here by myself. Okay. So if we didn't hit anything, we definitely return the intersection record. And obviously one thing we're going to be doing here is we're going to have emissivity. It really doesn't know what that is. It upsets me. It upsets me because it doesn't know what it is. Oh, because scene here, I see. Scene here is a template parameter. Well, let's give the IDE a bit of a clue, shall we? This is an optional thing. It is an optional primitive intersection record, and I don't like that because this is the first time that we actually have something which is coming from a particular implementation. This is the OO implementation, but to get us, actually no, leaving it auto means that if we change out what the hex scene is, as long as it looks like an intersection record, then we're golden. So I'm going to put the non-auto things here. We're going to have a material here. A material, go, do. I wish I could have music. I might be able to have music. All right, we got some. No, that's the whole point of this was no. I'm going to do mat.emissive plus the diffuse component, which is still not right, and we're going to run it again. Thank you, Yubi-san. Lovely. All right, everything still works. And a lot of this is just me being chicken about making this next step, because we're going to get into some horrible, nasty mathematical type nonsense here. So maximum number of reflections here. This is something I believe that's called Russian roulette, which is a rather unfortunate name, where depending on like the magnitude of the current brightness, we selectively randomly just stop tracing. We're like, well, heck, it's bright enough, and we've been going for a while. So, but it doesn't kick in apparently, at least in this particular implementation, until the 5th level of depth tracing. I am going to, for now, I am just going to do if ++ depth greater than 5, return mat.emission. Oh, well, these need to be up there now, don't they? I suppose in a very sort of strange way, this is a matte emission, this whole thing you're watching right now. Excuse my terrible joke. And we're going to close that off. Whoops, wrong key again. There we are. And we'll say to do Russian roulette with this F. And what is F over on this side? Oh golly, F is, holy cow, so unreadable this, isn't it? I am gonna load up my Rust version of this, and mainly because that will wake up Ubi-san and you can laugh at my Rust code again. Did I have it? Where did I have it? Okay, you can go in the background. You're doing sterling work. So path tracer, there it is. View, source, and bin, and path tracer.rs. Somewhere in here we will have the same kind of code. So we're calling radiance here. Max depth, the maximum bounce at the array you track. Yes, the max depth is the maximum bounces, but there are some things to do, and I forget the exact rationale of this. Obj.c. What is C here? Obj is the sphere. C is, oh golly, XYZ. Sphere's color. Okay, that's the color of the object, which seems awfully dreadful. How is the... So if the color bounding the maximum reflectivity is P, if some random number is less than P, then we immediately reduce the brightness of the object by... Oh, no, this is doing some kind of super sampling, I think. Like, we're multiplying by 1 over P, so we're dividing by P. Oh, golly, I can't remember. I'll be honest with you. There's some cleverness going on here, and I'll have to go and read up on it again, because at one point I understood this. As you can sort of tell, the names are familiar. Let's go and again have a look at my Rust code. And oh, cat, hello cat. I don't know why my cats, they want something clearly. So let's go and have a look at the radiance function that I wrote in the Rust world, which I think is in renderable. Renderable. You see, that's the kind of name. This has been years since I've looked at this, so we can see the sort of emergent behavior of me designing the same thing twice. So apparently I had intersect, which returned an optional F64, and then a separate thing which, given the distance, would get the hit. That's an interesting observation there. I separated the intersection part from the, and now get me the normal and the material, all that kind of stuff at that point, which makes sense maybe for spheres, but for some objects, by the time you've done the intersection, you probably need to return more than just a float to be able to work out what the heck you were doing before. Yeah, stealing code from yourself, right. Identity, some kind of magical number which was used by Rust for syncing. Is emissive apparently is important. I don't know why that's a separate thing. Random emission. I don't know if I was starting down a more complicated route here. Well, that wasn't the right one anyway. What do we got? Geometry, lib, math, scene. Maybe scene? Radiance. Oh, I've got like shadow casting in here. I don't think I did that kind of stuff. Sampling lights. Yeah, I'd forgotten I did do some of this work. So I'd obviously augmented over and above what I thought I'd done. I'm getting old and I can't remember. When was this written? Git log 2018, but I think that's just me like literally updating it to make it work with newer Rust versions. So the last time it was 2015. All right, I can't remember what I was doing in 2015. But apparently I did more than I remembered. Why did I opt to move from Rust to C++ for this? So this is not. I'm not trying to write a ray trace here. I'm trying to like show styles in C++. So it's more for a talk on CppCon, and like my Rust version is terrible for all the reasons. I was learning Rust at the time. That's why I was implementing this. This is just a thing I've done a number of times in a number of languages, and I enjoy the process. It's a simple-ish project. with some interesting trade-offs that you can make. And I'm doing it in C++ because that's my primary language and it's what I know best. And I'm using it to work out, or rather compare and contrast different implementations of the same thing and what repercussions you have if you decide to use approach A versus approach B, where approach A may be like OO, like we're doing now, like everything's on an object and we're passing around virtual methods and we're doing all that kind of nonsense, versus, you know, like a full statically known ahead of time scene where we actually compile everything into the code, which is an approach I know a friend of mine who's done a similar thing in Go. He's done with to some great to some great effect. Why don't I use git grep? Git grep radiance. That's the best way of finding where the heck radiance is. So, lib. Oh, of course it's in lib. Oh, of course. Where else would I have put the radiance function? All right. Oh, look, comments. Okay. So max reflectance. Here we are. This is you can see the shades of this kind of stuff here. So it's either emission or 0. If emit is a bool. I don't know why that's specified. We get a color, we get a max reflectance, and oh, I see. Okay, so we do some level of when we're reflecting, we look at the reflectivity, and the reflectivity, of course, is based on the color of the object. If the color is jet black but shiny, then it doesn't matter. Shininess doesn't affect it because everything's going to be multiplied by that black. We're not talking about specular highlights here. We're talking about like mirror color here. So if it's jet black, then there's no point tracing more than that. So we might as well stop at that point. So once we've got above level 5, we get the next random number. We say if it's less than max reflectance, which is the max component. I don't know why that looks like there should be some other number in there. I think that's just broken. Max reflectance. Oh, no, I see. Yeah, so like the max component is like the brightest color that this object could contribute, right? If red was 100%, black, red and blue and green was 0, then the red is what's going to cause us to for the results to still be visible. So what we do is we roll a dice and we say, well, how much can the next ray possibly contribute on top of what we already have if we're reflective? And as the brightness of our object goes down, it becomes less and less likely that we bother tracing to the next status, the next bounce. And so if we choose to not trace on, we're just going to scale up our color a little bit to account for the fact that, well, okay, see, this is not where it's not working all that well in my head. There's definitely some sort of scaling up where it's like, well, we're undersampling here. We're deliberately choosing to cut the number of samples we're doing off because we rolled a dice and it was very unlikely that it would ever contribute, but we're going to scale up whatever we currently do for the next bounce, is what I'm interpreting that. But I don't know if that's right. And yeah, for PBR, metals are usually dark with high reflectivity and smoothness. Yes, physical-based rendering is PBR for those, not perhaps blue ribbon, as some of us might be thinking. Okay. Well, thankfully, past me wrote some nice comments about this, so I think we're going to be stealing a lot of this. We're stealing an awful lot of this. So we're going to just do diffuse for now, because we're going to assume everything's diffuse. I've already ignored this bit, but whoever got fired for pasting Rust code directly into a C++ project, right? So we do need a random number generator. So let's type name that in. Type name RNG and passed in a RNG and RNG. And we're not maybe unused anymore on the depth. Excuse me. And we're obviously going to need to make this chap also take a type name RNG. And it's going to take an RNG and RNG. And then we're going to pass the RNG down here. RNG. Actually, no, that's not, because we need a different RNG for each of, well, we don't pass one into render, because we need to actually have a consistent known one for each pixel. Excuse the screaming children outside. So I'm going to make a call right now, at least to start with, that the RNG we're going to have is initialized per pixel, and we're going to have a stirred, well, let's include random up here. Random, thank you. And who among us can remember how to make the what is it? PT MT Mesen Twister there. Oh, thank you. 1930-37. Of course, I love C++ sometimes. Isn't that so obvious? Okay, we're gonna get rid of that. And if I can find myself again, for some reason my IDE has lost a key press. So RNG. Okay. Now, if I remember rightly, we need to initialize this with some magical numberings. So is this going to complain? We generate a predictable sequence of values. Yes, I want that, but I actually want it to be related to this. So we're going to say we're going to have a seed of x plus y times width. Right, so each time we run this, we're going to have the same random number. And then if we do go down the route later on of having like multiple threads, we know that they're not using non-deterministic random number generators if we like render the pixels out of order. So there's our random number generator. I don't know how expensive that is. We can come back to that. That would be an interesting thing to do, right? How much time have we got? Oh, it's now we're an hour and a half in, and I'm a bit further than I thought. I'll be honest with you. I thought we'd get caught up in some dreadful troubles. I definitely don't want to initialize with random device. Random device, we're going to get a genuinely random number from the system, and that means it'll be different every time. And I definitely don't want that. It's also super slow to do that. I know that one, as it's reading from like a file system, which may be like dev random on Unix. So I think that's all we need to do for that. So get a random polar coordinate. Yes. Now this RNG, of course, we need a range. Yeah, MT is definitely expensive. I know that, but for now, it's a good null start, right? I mean, it's a whole bunch of ors and shifts and exclusive ors, but the quality of it is not that important right now. We can probably come up with probably what we should do is just build a giant array of random numbers and say, here's your random numbers, go use those. But for now, it doesn't really matter. So we're going to get a random polar coordinate. Now, there are definitely ways. All right, to the internet, I have to expose you to my lack of knowledge of how to write C++ code here, because that's kind of what this is about. Oh, I seem to have lost... Have I lost my web browser? Yes, I have. Okay, let's go and get another one from the secret screen that you can't see. All right. So, stood random range. I'm sure there's some things to do this. Oh, I definitely don't want that. Uniform, aha, somewhere like this. Someone's going to tell me in the chat in a second, aren't they, what I need to be doing. I want a... Okay, min stood range. Maybe that's okay. I don't know. We'll come back and actually pick a different one. Non-deterministic random numbers. We don't want that. We actually want one. Uniform real distribution. Sounds good to me. And... we construct it with what? Gets or sets that. Why is this so complicated? Thank you. This is what we want to see. Okay. Beautiful. Copy pasting code from the internet since 1980. Well, no, won't be 80, will it? 1994, I think, would be the earliest I used the internet. Okay. Get a random polar coordinate. Hey, some code actually exists. So we want to get so this is going to be polar, and it goes obviously from 0 to 2.0 times m underscore pi. Yuck. And then we're going to say auto r1 equals polar. Oops. Polar dot. No, crikey. How do we do this? Dis of gen. Oh, we just call it. It's a function. Why does people think that's a good idea? I like to have names for things. RNG. So there's our first one. And this is... I'm presuming that this is like as trivial as I think it's going to be. It just remembers MA and MB. And then does the needful thing. Yes. And presumably operator paren paren. Where are we? Operator paren paren. Constructor uniform real. Result type. Operator paren paren. This operator blah on that. And it does... Yeah, it does the obvious thing. Good. All right. So it's basically all going to optimize away. At least in my instinct of what this is going to happen. So then we need to do 0,1.0. And I'll come up with better names for this in a second, so we can get rid of you now. Auto R2 equals unit of rung. Auto R2S equals squirt of R2. Not that R2. Create a coordinate system, UVW local to the point, and where W is the normal... See, I understood this at one point. Pointing up from the sphere, and the UV are orthonormal to W. So what we're going to do is we're going to build, like, if you get your little fingers out with your three fingers pointing, you know, one of them things is going to be your index finger, your thumb's going to be another direction, and then your middle finger at, like, another 90 degrees. We're making an axis here. So we just pick the normal at the point. Then we're going to pick an arbitrary non-zero preferred axis. It really doesn't matter because we're just generating this kind of like a coordinate space where the only thing we really give a monkeys about is the normal. Everything else is just a plane around that point. Because what we're doing, I should probably explain what we're doing here now I've remembered what we're doing, is that we're going to try and find a random direction where we're going to continue casting on from this spot. And we want to make it... Yeah, so we're going to carry on calling radiance onwards from this point, in that random direction. I'm gabbling a bit here. I'm sort of jamming and thinking. So anyway, we're going to make auto W equals N1. Now N1 is the normal here, so we're going to say that's where do we have ray dot direction dot dot? No, it is hit dot normal. So we're going to take a copy here, importantly. This is the W axis of the UVW. So W is going to be up away from the point on the sphere where we've hit, or sphere, of the object. We don't care what type of object it is here, only that we have a normal. And then we just need to pick two other directions that are both 90 degrees from it. So this is going to remain constant. So I'm going to just make this const auto ref for now, and we might actually refactor this in a second. Right hand roll. Oh yeah, it may be right hand. Sorry, I had my left hand up, didn't I? But not only do I not know my left from my right, I don't know my left hand roll from my right hand roll from my this, and you know whether I'm gripping whichever way. It seems hard to believe that I have a degree in physics, but I do. I can't remember which is which. So we pick an arbitrary non-zero preferred axis. So we just pick anything. So if we're saying if X is above, so we're I speak in English now. So const vec3. I don't know if it's going to be able to work this out. U equals, now this is a ternary operator here in Rust, so we're saying if there's any X component at all in the normal, then we're going to pick something which is we're basically just trying to make sure we don't pick one of the two other directions to be exactly the same direction as the current normal. So we're going to say n1 dot if n1 w dot x if fabs of that is greater than 0.1. We know that there must be some kind of X component in the normal, which means that we can pick something which definitely has no X coordinate at all. We know that we're not going to be collinear with it. At least that's the theory here. I'm questioning it now as I run it through in my head. So otherwise we're going to make a vec3 0, 1, 0, else vec3 1, 0, 0. I think is what that's doing. Let's just go to the end of that line. Aha! And then we have to cross that with W. So all of that dot cross W. So that takes the cross product with anything that was just pointing away from the normal, and we get something. Thank you, Professor Retroman. Yeah, this is not really what we're trying to do here. I'm trying to use standard features if I can. I mean, it's great to have fast random number generators, but this is more about like things that are available for me right now that I can pick up and use without going to too much trouble and effort. It's more about the arrangement of the code, although this bit is fun, right, if we can get it right. So this actually could be auto, because we can, and we're going to say const auto v equals w dot cross u. Lovely. Construct the new direction. So sine and cosine. I see. So now we've got our position. We're going to make a new direction. So we're going to say u times r1 dot cos. Okay. So r1 is that random Oh, wait a second. Did I just pick? I did. I think I did a mistake. Made a mistake. Oh no, that is N1. Good. All right. Okay. No, I didn't. I thought I was getting N1 and R1 mixed up. I mean, if you make variables that are called N1 and R1, then you deserve everything you get, in my opinion. So that's my fault. I think I've confused myself, and now I think I've unconfused myself. Cool. Let new direction equals that. Const auto new dir equals u times cosine of r1 plus times r2s plus v times sine of r1 times r2s plus w times 1 times square root of, I'm trying to translate one language to another here, of 1 minus r2. I think that's right. So we're taking u and v, and we're getting cos r1 times r2 squared plus v lots of sine of r1 times r2 squared, and then plus w times lots of 1 minus r2. Wonderful. Now that should be normalized, I think, but I'm calling normalized here, which is silly. But so auto new ray equals, I will use ray colon colon from origin and direction. And so we obviously have the hit pos hit dot position and new dir, and I'm pretty sure that's already normalized, but I'm gonna, given the number of things we've just all done in a row, to do check. I think this is normal already, question mark. Excellent. So we have a new direction and we have a new ray based from that direction. Splendid. Doesn't it have norm R2? Ah, yes, Victor, you might be right. So R2 is just a random... Yeah, maybe. Yeah. I'm going to get rid of that to do then. I think you're right. Right enough for me not to worry right now. And so now we're going to say emission equals emission plus color times scene.sample light. So that's gone. We don't do that in our... That was obviously the thing that I added in, which made it more of a ray tracer than a path tracer, at least in my understanding of those terminologies again. But now we are going to say emission... Where is that radiance thing? Color equals color times radiance. Oops. Now I'm getting all a bit flustered. Color equals color times that, and then this all fell through emission plus color. I see. So we're now actually just going to return what we do over here. Let's go back over to this horrific travesty of code. So believe it or not, that is actually all compressed over here. So we're going to return mat.emission. Well, we put it down here. Mat.emission. Brilliant. So that's the baseline. That's how much light we emit. Doesn't matter where the ray come from. We're a light source and we're making light. Otherwise, we're going to return F. And now F on this one was the color, which may have been fiddled with. So we're going to say no longer this power nonsense over here. We're going to recurse. Hooray! Radiance of scene RNG. New ray. And depth plus. Well, no, we've already incremented depth up there, which I don't really like. Is that it? What does the compiler say? Well, first of all, have I just yeah, that's fitting nicely. Okay, let's get rid of that. I don't think we need that open anymore. Whoops. Okay, it's quite dense code. Let's see what the compiler says. Now, we're going to get black out of this because there is nothing with emission right now. And it's going to take a little bit longer. It may even take an infinite amount of time. Wow, that did take a lot longer, didn't it? I think we're going to have to start running this with optimization on, or with a smaller image. But talking of our image, there is our image. Let's pin this on the top. Maximize. Always on top there. Yeah, there we are. Another thing we're going to have to do is we're going to have to start sampling this thing. Because at the moment we're not doing any sampling, which means that the chances of us actually hitting anything that is bright is diminishingly small. But we'll get there. We'll get there. I am going to make this half size, which is pretty horrible, but it's a necessary evil for this to sort of remain somewhat interactive. And I might have to build it and run it in release mode in a second. Okay, so there is a smaller in here sphere. Can I zoom in there? Yeah, okay. I wonder if it'll keep the zoom. Something like that. Still black. But now, for my next trick, ladies and gentlemen, and those in between or around, I am going to put one of the spheres as having a small amount of light coming out of it. 0.1 light units for what it's worth. So, small drum roll. We can see! Oh my word, it's only working. So, exactly as expected, the sphere... I'm going to bring this to zoom up. A black square planet. Thank you, Andreas. Yes. So I'm going to zoom into this so that you can see the artifacts that we'll see. All right. There's been... EOG here has done some amount of blending here. But so for every pixel where we hit the first sphere, we are going to get 0.1 light units immediately, right? Because we're always emitting 0.1, and there's no shading on that. It's just like as if you had one of those sphere lights, light diffusers that's spherical, and you've got a light bulb inside of it. The whole thing's just at a particular brightness. Of course, that's the first hit. If we stop there, we would just see a white circle and then some blackness. But what we do after that is we say, well, some of the light may come from elsewhere, in which case we bounce around. Now, on the right-hand side, let's imagine we were this little dot here on the side of the sphere. I can't believe how well this has worked, to be honest. So our camera ray has hit where the mouse pointer is now, and it's hit the sphere, which is pointing almost directly at its neighbouring sphere. And we've now bounced a ray away. And now, of course, of all the directions you could be bouncing when when you start pointing towards a sphere which is like only a centimetre away from you, almost every one of those rays is going to hit the sphere opposite you. So you're going to actually go and get the colour from that point. And the colour from that point, of course, is 0.1. And so the whole chain of light we've now traced from the point through the arrow of the mouse pointer, assuming you can see the mouse pointer. I don't actually know if you can. We've picked up the fact that there's going to be a yellow tinge to it because the sphere on the right-hand side is yellow. And we said, well, what light is arriving here? I don't know, let's just look around and see what light there is. And we've hit this bright sphere next to us and gone, oh, there's some light. And that's great. And it also means that these red dots that we can see are where the light has bounced at least twice, because we've got the brightness of the sphere itself, which is just plain dark grey. That light has hit the sphere next to it, picked up some yellow hint, then it's bounced back onto the sphere and picked up some of the redness of the sphere itself, the sphere's of intrinsic redness. So I'm pretty excited by that. So the next obvious thing to do is to configure this to run in release mode, which we currently don't have. I'm very excited. I'm so pleased. This is well, we're 1 hour 44 into this. I need to go to the bathroom. I need another cup of tea. I've forgotten to have lunch before I started doing this. I don't know why I pick up lunchtime as this. I don't know why I schedule these as lunchtime and then forget beforehand, but you'd think I'd learn. We are going, and we've not really done much C++ here, really. I mean, you've seen just how I work in my mindset of C++, but let's get it in release mode. So I'm going to have to remind myself how to do that. So let's go to settings, and somewhere in here is CMake settings, and CMake, we want to add release build, use B, yeah, default J4, beautiful, lovely. Wait, 1 Mississippi, 2 Mississippi. We should now get a little option up here when the IDE wakes up again. No, still hasn't. Still loading. How about now? Yay, release. So release PT3 ways. Off we go. First time I've built this with the optimizer on. Got to stay hydrated, yes. Tea. Tea is the key to hydration. At least in my world. Okay, so that ran almost instantly, which is good news because we're about to slow it down so much that you'll see why I bothered to sort that out. What happened to EOG? Did it finish? Oh, Sad Bear is sad. No, not that. Although that is an awesome picture. This, if you want to crash X, I have this 70. Hang on, how big is that? That is, yeah, 58 megabyte JPEG of a very high quality resolution shot of a 6509. So that kills EOG. EOG just naively asks X to make something which is however many trillion pixels by however many other trillion pixels and crashes the X server, which is nice. So don't type EOG on that. Use something else. Use GIMP or something. Images. It's in CMake. Oh, and of course I have to remember that. I'm in the wrong directory. That's why I'm not getting PT3 ways, EOG. Now it's auto-completing. Now this is going to be in the release directory. Yes. Okay, we've got the same image. Hurrah. Well, near enough the same image as that I don't care. So now, of course, what we need to do is add sampling to this. Sampling. Like some kind of 80s pop mega mix. I'm sorry, I'm going slightly silly. Which will be up here somewhere. So we get the radiance from a single point, which obviously is not what we want at all. So I'm going to extract that into a variable. I know it used to be in a variable. This is going to be color equals that. And this is no longer going to be that. That's going to be that. It's going to be auto. So thank you very much. In fact, we're going to do vec3 color. I can't believe I spelt it the American way. I am a disgrace. I am so sorry, Victor. That's not really what you needed to hear, is it? I appreciate your tolerance. Okay, we're going to do for int sample equals naught. Sample is less than, for now, 100 plus sample. This is going to very quickly become configurable. Actually, let's at least put it in a variable up here. Const in num samples equals 100. Num samples. Color plus equals radiance. And of course here I am deliberately, purposefully not remaking the RNG, so we don't do the same sample over and over again. And then we're going to say afterwards const this is going to be color times 1.0 over num samples. We know that I haven't done integer division for my math library. So I'm multiplying by the reciprocal, knowing ahead of time that that's going to be the better thing to do. So what do you reckon this is going to look like? Is this going to be better? So what we're doing now is we're doing 100 and then we're taking the average. And you can see it's starting to get there. If I could remember how to maximize the window. And See how nice we're getting this little bit of blurry redness here. It almost certainly doesn't come out on the video, but there's a little bit of redness here where the colour between the two objects is bleeding. Now, of course, it's worth saying that the object on the left-hand side, the white object, apparently white object, is not really any realistic material. It is something which is bright white, emitting light, but it has like a red patina of itself, which is I don't really understand. So that doesn't make any sense. But you can see how, I mean, first of all, this is a very noisy picture. Even with 100 samples, that's not really enough. And, you know, secondly, that we've got very unrealistic images there. That's interesting. So somebody's just said, Christopher Ward has just said, the Mersenne Twister is 5,000 bytes worth. So, okay, why don't we then switch that out for something else? Let's go and have a look at some of the other choices that we have, although I am desperate to finish this and at least we'll pause, get some tea and all of that stuff. But I'd like to get one of these. Which of these seems to be the least rubbish? Should we try the Ranlux 48? Ranlux 24? Which of these do you reckon? Minstud Rand, newer minimum standard. Sound okay? Let's give that a go. Just literally giving this a shot just to see if it makes any difference at all. Of course, we should print out how long the process takes as well. It would be a useful thing to print out. Oh, let's get this one back up. Yeah, okay, so at least it works. It's got a different image. It may be faster, but we haven't done any kind of testing. That's it seems not unreasonable to use something called Minstud Rand. So let's make this 1024. Nine. 10. So it's about 10 seconds now, which is on the borderline of interactive fun for me. I don't know about you. And now we're getting something which looks a little bit more... Well, it's still very noisy, and this is most of the fun of a path tracer is getting rid of the noise. That sometimes it's filtering, sometimes it's sub-pixel sampling, which we're not actually doing here. Right, yeah, you can learn Java. Please, learn Java. Java's a great language. I enjoy programming in Java. It's not really what I'm trying to talk about here. But it's a fine programming language. It has many applications, and many of the high-performance systems I've worked on have been in Java. But this is all about C++, like you say, Luca. So that is pretty much as far as I was expecting or hoping to get. Let's get rid of that horrible manifest constant while I'm here. The other sizes come through from the output buffer. And so I'm going to say int num samples equals... that's a weird thing, isn't it, actually? The number of samples. So definitely rendering to the buffer makes sense, because the buffer is of a particular size. I don't imagine that... So can I reseed the generator rather than making a new one each time? It would be interesting to know if that makes any difference. Whether constructing it... I mean, let's have a look at what the heck this is doing. So the constructor just calls seed. So I'm guessing that that doesn't make any difference whether you reuse the same one over and over again or not. Certainly the compiler is smart enough to not I'd imagine it's smart enough not to do anything else silly. I don't think the destructor does anything, but it's a thought. Okay. I guess I could use those uniform distribution things here, you know. I just realised that would be kind of sweet, wouldn't it? Anyway, I'm thinking out loud now. I want to get the number of samples, and I want to know where they should go. It doesn't seem quite right. In fact, so I'm not going to do it. Int num samples. There we go. That's the best way to do that. I'm going to get rid of you, and now render down here is going to have the 1024. Of course, I'm only pushing numbers around here. I'm not actually doing anything materially better. I tell you what's bugging me though is the fact that this material, which is bright magenta, hasn't got a magenta light source. So let's at least change the light source to be magenta, right? And let's run that. And let me get EOG back up again. So it hasn't finished running yet. 1 Mississippi, 2 Mississippi. There we go. So that's slightly better. Yeah, making it thread local. I don't think thread local helps. How would so Andreas, you've made a point about making presumably the random number generator thread local. As far as I can tell, that would make it much more expensive because it'd have to indirect any access through the what the heck's it called? The thread local register. I can't remember what it's called. So so that is I mean, if we're going to spawn multiple threads, I would put the Mersenne twister on the stack of the thread that's actually going to be doing the work. So of course that is an obvious next thing to do, is to say, hey, how might we render each of these individually, maybe line by line? How would we like put these onto different threads? Now, if we look at small point, let me get rid of this now. Up, down, minimize, no, always invisible workspace, always on top. No, that's the one I wanted. Go away. If we look at small point here, what this magically does is it uses this. Where's the pragma gone? Prag. Oh, I seem to have lost the pragma inside small point. That's interesting. Yes, it is looking at some weird circular 3D glasses. So yeah, there is some open MP pragmas one could use here, but it seems like the right way is to manually manage this, at least simply. So, for example, what if one were to spawn n threads, each of which was responsible for doing the y%n row? That's one way of doing this. Another way would be to post, a bit more like on the Rust view, various doodads. What are we talking about? Golly, I'm so sorry. Another thing would be to post like to-dos and just post 1,000, height to-dos to a shared structure and have threads just read from it until it's empty. That works too. But I tell you what, I've got quite a good spot here. I'm going to say, first diffuse material git pull. I don't know why I'm git pulling. No one else is checking into this. So someone's saying tying the random number generator to the thread will make your output non-deterministic once you start doing multi-thread. That's not true, Michael. No, because the entire state of the random number generator lives inside that object. That's not true, of course, of things like the standard C functions that use rand, but we're deliberately using stack-based random number generators who will be completely deterministic no matter how many threads you've got. I wouldn't share that random number generator with another thread. I suppose that's perhaps what we're disagreeing here, is that at the very least I would take this part here, this int x part, that would be one thread, and so a thread would know its identity, it would know which line it's on, and it would construct a random number generator for itself for that pixel. Maybe that makes more sense. Yeah, std async is another choice for doing this. Yeah, so far this is absolutely deterministic, and any sort of threading I would choose to do would be similarly deterministic, because from this point, I would never separate out the rendering of an individual pixel to multiple threads. That seems to be like a bridge too far. So whatever's going on, any one pixel will be rendered by exactly one thread, and that thread will know its identity and can construct a random number generator that will be deterministic for that thread. I hope that makes sense. I hope I haven't missed out anything there, and I hope I haven't misrepresented what you're saying in the chat there. So yeah, I'm going to check this in, and you can play along at home, actually, if anyone wants to have a go. And this also opens up questions here. So like this, I've hard-coded the material here. And I wonder if that's how it should be done. Like this horrible code that we're copying from on the right hand side here, which like has very special cases for if it's specular or if it's not specular or if it's refracted. then it sort of has completely different paths. And I wonder if we should. I would like to generalize that. So I'd either like to generalize the material so it could encompass everything that could possibly come out of a material, rather than special casing for am I diffuse or am I specular. Yeah. So Michael, again, your point. The work queue would know which pixel it's dealing with, and you can see the random number generator is defined by which pixel is x and y coordinate. Maybe again we're talking with the latency here. I think we're talking maybe at cross purposes here, but like the random number generator is its seed is tied directly to the pixel that it is rendering, so it will always get the same sequence of values for that one pixel, regardless of which thread it is. Unless I'm missing something again in what you're saying. Yeah, and I'm trying not to get too caught up in the threading part of this, because this is not really the direction I'm trying to go in. I want to get to the point where I want to. Well, yeah. So someone's made a comment about having 1920 by 1080 threads for a nice real time fast rendering. Well, a lot more than that for real time rendering. But that's what GPUs are doing these days. That's where we're getting like the ray tracing being done on GPUs, where there are so many things. Yeah, I think we're now all out of phase with each other. I apologise for my talking being out of phase with the chat, and if there are cycles there going on. But yeah, we've got a choice here. Either I come up with like the one Uber material which everything can just use, and then that disappears, and we get rid of this. This whole block of code becomes just something which is common to all types of the renderer. Or this is actually an opportunity for the material itself to be extracted and be like, hey, you tell me what I need to do. Do I need to diffract? Do I need to specularize? I don't know. So I don't think I'm going to go down that route, but that's another like place where potentially you could make a different call depending on whether you're going down the pure object-oriented route or whether you're going down functional or procedural. But right now I've been talking for 2 hours. I've got something which is working, and I'm super excited about it. I'm going to take a couple of minutes break to go and do needful things like making tea. So you're welcome to join me for whatever I do next. I might put in some benchmarking stuff, just to have a place to experiment. I might put in some threading. I do want to like reproduce that small point scene, the original scene you see when you go to small point. So that'll probably be the next thing I do. Yeah, I'll do that next, and then we'll go from that. So I'm going to come back from here. OpenMP is being suggested here. That was like the original case. There's a lot of things that OpenMP assumes or presumes, or you have to put in like a whole bunch of lists there, and I prefer not to use it because it's not part of like the standard language, at least at the moment. But I'm going to go off. I'm going to say AFK for 2 minutes. It'll be less than 2 minutes probably. Back to get small put scene in completely. Oh dear, that's terrible. Alright, I'm leaving it though. So I will be back very shortly, my friends. Thank you for watching so far. Back in a sec. Alright, what am I missing? OpenMP... Security, yeah. Interesting. Marsaglias. I've never heard of that one before. If it's not in the standard, I don't think I'm going to be experimenting with that right now. Oh, I didn't write my little message. Okay, let's put that back to normal size. So, let's get the small point, which is a rendition of the Cornell box. Let me show you what I mean. Cornell box. So it is, you know, something which looks like this. It's a real actual box that was built and photographed. Oh, give me the Wikipedia page then. And it has, you know, like coloured walls. It has a light at the top, and it has various different textured balls in it, so that you can see the interplay of, like, there's like a greenish hue here, there's a reddish hue here, and a reddish hue here, and all that kind of stuff. It's pretty awesome. And it's a great test of, like, seeing colour bleed. So this greenness you can see up here, although that looks like it's reflected, to be honest. But Small Point has its own version of it, which is the one and only scene that's built in. This thing here. Radius, position, emission, colour, material. So that's its list of spheres. And I'm still sort of semi-AFK because the kettle is boiling. I shall be right back in a sec. Stage 2 of tea complete. Now I mustn't forget about it like I did last time. So diffuse. There's one specular and one refractive. So obviously we don't have those yet, which is something else to think about. Okay, sorry, and they said something about do not have to declare anything as long as you write into the data structure declared before the loop and don't do concurrent writes to it. Well, that's what I'm doing here. Like, we're plotting concurrently to the same thing. Now it's safe. This particular one is thread safe, so I know that that's okay. So we could probably do something with a pragma there, but I'm still, for now, I'm going to leave that alone. I don't have enough CPUs on this laptop to actually make it worthwhile, and if we look at currently, like if I had 16 CPUs, that'd be great, but I have 4, and as you can see, most of them are taking up doing video streaming right now, so I don't want to... no, what do I do? So threading is not going to give us the giant win you might otherwise get. At least right now. Obviously, once I'm running on a more beefy beefy machine, it'll be a different story. Okay, so there's our original scene. I'm going to comment this out because, you know, for posterity, it's nice to have something to come back to. And then I'm going to basically copy paste this nonsense in. So let's just try. So the small point box, Cornell box, is built out of spheres entirely. They're just gigantic spheres on the left and the right and the top, the bottom and the back. So huge that they look effectively like flat surfaces. Now, I want to get to the point where I can replace those with actual flat surfaces. That's the whole point of this, is I want to have more than just one type of object in my scene graph. And then that's where the fun is going to start, when we start having like actual dynamic dispatch of what type of rendering and intersection things are happening versus just everything being a sphere. So... but we're going to start with exactly what is in small point here. So stirred, make unique, sphere primitive, and of course that sphere primitive really should be in, not defined in an anonymous in an anonymous namespace. There, I said it. Ha! All right, so we've got a sphere, and that sphere is of vec3 of 1e plus 1e5 plus 1, 40.8, 1.6, and radius 1e5. Okay, then it has a material. And now, are these materials the same? Yes. I know, 752525. 252575. Yeah, it would be so much easier if I could be bothered to write a parser here. Maybe I'll bring in Hannah's regular expression library and we'll write a parser. Material, something. Okay, is that basically the right form? I think so. That's basically the right form of what this needs to look like. So a material has emissivity. I can't talk. So I think I'm going to make some helper functions for material, just for later. I'm going to have a static material diffuse vec3 const vec3 and color, and it's going to return a material of vec3 of nothing and color. So that way I've got a quick way of naming a material with a sort of named constructor, and if later on I change, you know, to specular, like the constructor can be named and say, like, I just want a shiny material, I want a non-shiny material, that kind of thing. So, oh, of course, that can't be called that. Blast. Okay, that's poor naming. All right, we're gonna call it make diffuse, which I don't love now. That makes it less fun as far as I can tell. Vec 0.75, comma 0.25, comma 0.25, and this is vec 3. Okay, so that's one of our things. Now, true to my form, I'm going to just run that and make sure it compiles and get a black. If you can even skip the vector material as an aggregate, that's a good point. Yeah, it's just that I want to skip over that that first emission part, because it's almost no material ever will have an emission, and I have to specify both of them every time, which is a pain. Thank you. You saved me there, Ildad888 or Lidad. Thank you. You saved my tea. It is quite strong. I like it strong, but it would have been a lot stronger if I hadn't have. So yeah, we have a black scene because nothing is emitting here. There should be a teapot in the. There should be a teapot, and I will get the Utah teapot at some point, but not now. Okay, so this chap. I can probably steal the insides of that. It would be the insides there. That's also a 1E5. And its colours here I can steal, or I can just change them here. I don't like the point. I know they're trying to save. Okay, so there's another one. So that's the left and that's the right. And then we're going to have back, which has this inside the things, and that's grey, so that's point. Did I miss that out? 752525257575. No, that's 252575. I mean, ultimately this doesn't matter exactly, but we're just going to try and get something that's a bit more interesting than what I can dream up. Front. Interestingly, even though you don't see the front, it's there, because otherwise it's a source of reflections of light coming back into the box, which is kind of interesting. So we might have to be careful about where our camera is positioned, because if we're not careful, we'll be outside the whole box itself. Okay, and that's black. So that's just completely black, that front box. Bottom. I said bottom. Front, bottom, and bottom. Not front, bottom, that's even worse, sorry. Forget what I'm saying. Looks like that. And the bottom is grey, apparently. 0.75, 0.75, 0.75. Never in the field of human history have so many people watched somebody copy-paste their own... Well, this is not my own code, actually. This is, of course, the original small point code, but... Come on. It's also 0.75, 0.755. It's diffuse. Okay, so now let's get the light. because that's the one I'm interested in. The mirror and the glass ball I'm less interested in, you know. So the light is a total hack where it just about pokes through the ceiling. It's a sphere that's poking slightly through the ceiling so that you get like a little bit of an oval coming through. And it is what size? 600 apparently. And it is 12. It has an emissivity. So we're just going to use material. And like you said, we can, whoever said it, I can just use the braces here because it's expecting material. And here we actually do want 12, 12, 12, and a vec3 of 0, 0. No, just a vec3. So this is like 12 units of brightness white. Well, it would help if I could type. Oh. It's not happy with that. Let me just put material in here and see what if it gets... Yeah. Alright, for whatever reason, it doesn't like me missing out the word material there, and I'm not going to debug that right now. Alright. So we should have an empty box. Oh no, I tell you what we haven't done is we haven't put the camera in the same place. Otherwise we're going to get very sad output. See how much longer it's taking already? That's interesting, isn't it? Of course, what was happening with our previous scene is the vast majority of those rays that we were casting didn't hit anything, and so they just returned 0. Now every ray we cast is presumably not only having to check through a whole bunch of very large spheres, but is hitting something, and every bounce thereafter also hits something. So suddenly we're taking forever, which is sort of sad. Yeah, Russell's teapot is a philosophical thing where I think Russell conjectured the existence of a teapot somewhere like orbiting the Earth that we never saw, and if we don't know it's there, do we? If we have never seen it, how can we conjecture it's it being there or something? Yes, that's right, Luke. Luca's on the case there. Wow, this is taking a lot longer. We're going to go to 10 samples, and I'm going to rerun because that's too long for my blood. I am in need. Now, if you think about what's happening in this box, almost every single ray is going to miss everything, right? It's going to hit a wall, it's going to go somewhere to hit another wall, hit another wall, hit another wall, and unless it hits that light, the whole chain of rays will be considered to be like not worth lighting. And indeed, we have a black image. That's sad. Well, we need to put our camera in the right place, and then I will be more happy. So where does the camera start? 50, 52, 295.6, obviously. So cam pos. So that's currently hard-coded in my code. And now it's going to be hard-coded in a different way. Yuck. So I think probably I should pass those in. What do you reckon? We've passed in this int num samples here. I think, yeah, we're going to do const vec3 and cam pos, const vec3 and cam dir. Whoops. And these two get shipped out in... Oh, and all this const expra stuff starts going away. Oh, I never really liked it. Render scene output, so we can paste that there, and this is cam pos, cam dir. These don't need to be const expra anymore, but they can be. So that's as they were with our test scene, so they should really be part of the scene, don't you think? I think the camera should be in the scene. Maybe we just pick which point in the scene is the camera, but we'll worry about that another time. So we need the camera position to be this, and auto camder equals vec 3 0, 0. Whatever this says here. Okay. We're not doing subpixel. Yeah, printing out progress would make sense as well, although that will get in the way, unfortunately, of some of the work for threading. But again, I've said that we're not worrying about that. But yeah, I think percentage done would be useful. Oh, look! We got a thing! Oh, it's not a very good thing. I mean, we've been uncommonly lucky so far with all of the progress that we've made. I'm staggered to see how well this is working. But, yeah, now the really tricky part comes, is how the heck do we debug something like this? Now, we do have tests. Those tests all passed because we haven't added any new ones for this. So I don't know if I've typed in something wrong here when I transcribe from the position of the box or not. Yeah, it's another square planet. It's a good way of putting it. I mean, we've definitely got a hint of red on the left-hand side, a hint of red, but it's so much brighter than I could possibly imagine. I can't think what's going on here. I can only assume our overly bright sphere primitive that's the light is doing some kind of crazy dominating. So why don't we just play around with that for a second? Let's make this always on top. Now this is going to be far less about C++ and more about like how on earth does one go about fixing a problem like this. Oh, that's too much. There we are. That fits. Right. So I'm going to comment you out and we're going to run you again. And we'll just make sure that in the absence of a super bright non-diffuse material, that everything should be black. Yes, everything's black. But when we have some Gigantor 12 12 12, it does look like the back wall is missing. Yes, I agree. I agree that the back wall appears to be missing, which is another sort of disclaimer. Now, I'm wondering as well if this 12 12 12 is overflowing something. Now, I should be accounting for it above in a clamp, but I can imagine myself not getting that. So I'm going to put it down to 1 and make sure we're not overflowing. Yeah, okay, so it just made it darker. Interesting. So I'm really surprised that we're hitting this this sphere as often as we are. Because this is like, I'll put this back to 12. Oh, and the IDE's decided to have a moment. Yeah, there we go. It's just super bright. Now, I think we might be upside down here for a start. I think we might be upside down, but that's an easy thing to worry about. So that white sphere here, this white thing here, could be the light where we're just not doing intersections the same way. So that could also be in the front and the back of the other way round. Let's see how the direction is used inside small point. Oh, and I've made this always on top, so that's why I can't see my code. I mean, it could be that we're looking at the inside of everything. If everything's inside out, then the reflections... No, they would still be outbound. Yeah, they'd still be outbound. I was wondering if like the spheres all centering around like one point might be an issue, but they're not centering around one point. If anything, they diverge from a point. Well, that's no fun. Okay, so I should have copied these things across as I did them, shouldn't I? So let's put the comments in and let's play experiment with this. So this guy is left. This girl is right. This one is back, front, top, oh, no, bottom, top, and light. Thank you. All right. So let us take out what we believe to be the back wall and see if we still see the same result. Yeah, I don't think that changed anything. So we should take out the front. And well, actually, let's just make the front like bright white. And I suspect we'll now see that the back back wall goes bright white. There we go. All right, so our front and back are the wrong way round. So our camera is pointing the wrong way round, which is a perennial problem with this kind of thing. So I am definitely doing things differently when it comes to some of the work here. Of course, there is every possibility. So let's think about it. The camera direction is 0.04, which is looking up slightly, and -1 looking behind. You see, that doesn't make sense to me. I think that's exactly the wrong way around. I'm going to put a minus sign there and a plus sign there because it makes more sense to me. X, Y, Z. Z goes in. At least in the way that I've written my camera code, which of course is different. So we'll go and see. Well, that's not better, is it? I think it's fair to say that that is also not right. What are we looking at there? I can't imagine which part of the scene that could possibly be. That is a very odd intersection. And so this previously, what was, when I cavalierly, that's not a word, it was 001 was the camera direction we previously had. And that was definitely at a point. Oh, I wonder, I wonder if actually this isn't. So well, let's think about it. We've got a sphere that says it's on the left, and it has a. It is at position 1e5 plus 1, size 1e5. So that means that left is going to be. That doesn't seem right. That seems like the right one, if anything. Confused am I? Yeah, that's a good question. So someone said, what happens if I remove the left wall? So let's put that back and put this one back as well and then rerun. I'm going to make that like 3. So it's going to be darker than before because I'm only doing 3 samples. I just want to speed it up a bit to get a bit of turnaround. Hang on. That looks very different. All right, I'm putting it back to 10 because I'm changing 2 things at once here. Let's have a look at small point again and say, let's just make sure that I have got that right. All right, that's minus. Okay. Right, so we still have the left wall commented out, but we should be pointing the right way, the correct way. I guess that is the same scene, isn't it? It's just that it is the left wall that has disappeared. Curiouser and curiouser, said Alice. Let's just make sure right is right. Ah, yeah, that's right. Michael, you had a great point there. So Michael worked out what the view would be because these are all spheres. I'm thinking of them as planes, and of course they're not. Okay, so those things are the right way around. I wonder if the front and back are just the wrong way around. Have I transcribed it right, or is it actually, are they the right values? Anyway, is this comment right? So front and back are 1e5 is back, 1e5 is back. Front is minus 1e5 plus 170. Yeah, so it could be then mislabeled. But then, no, because then the colours would be wrong, because we know that the front is, what? We know that what do we know? We know that the front wall is the right colour, because the front wall is, the front wall's black, the back wall is grey. And so we would expect to see the back wall which is this one here, and we don't see that because we just get this black. So we're theorizing we're looking the wrong way. Why don't I put one of these? Let's put these other spheres in here, the actual ones that are meant to be mirrored in glass. And I was so hoping for a giant, you know, hooray! But that is not to have been. So let's put those two in. Oh, that's daft. Steal that. So these are going to be diffuse, obviously. I've had it so good so far, haven't I? 16.5, and you are that. Paste. You have a. Oh, they're both just grey. So, all right, we're going to make them both 0.999. No. 0.999. I should probably make a convenience method for this. Pasty, and I don't think I registered that they were actually the same colour. And this one is the same, but it's specular versus refracted. So you're doing sterling work in the chat there, trying to help me out. So let's see if we even see these spheres. My guess is that we won't see these spheres because they're probably behind us. Yeah. Okay. At this point, I will defer to my Rust implementation and see what the heck I did there. That's not that. It's scene.rs. No, that's not it either. Oh, I think it's in bin path tracer.rs. Is it in here? Okay, so this looks very similar. Would you not agree? 1E5, 1E5 plus 0. Diffuse, yeah. Black, blue, grey, whatever. Specular, refractive. Now, there's no promises that I got this right in my Rust code either. Yeah, look here. So let's have a look. 50, 52, 295.6, 0, minus 0.0421, blah, 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 minus 1 normalized. Yeah, see, that looks great. Does make me wonder if my intersection code is broken, and we're only now seeing it, which just would show how bad my tests are. So thank you, Victor, very much for joining us. I think probably I'm going to finish up in another half an hour, everyone else who's watching, because I think I'm about to faint of lack of food. And, you know, I think we're reaching a sort of a dead end here. Certainly I'm going to have to bang my head a lot more, but your help has been valuable, and it would be lovely if we could get this rendering the way that we know it can be rendered. So 27, 16.5, 47. It all looks good. So where is the light in my old code? It's this one here. 50, 81 points. Oh, have I got? Oh, that's really interesting. Look over here in my my light on the right hand side here. Rust says 1.8. In what context? I forgot what question. We're so far out of phase, I'm afraid, XOR. But you can see that I've reduced the size of the light in the case on the right hand side. Instead of it being a 600 thingamajig, it is a what is that? 1.5, a 400? No, 81.6 radius. That doesn't make sense. No, it's a 1.5 meter thing. Yeah, it's an actual inside thing. Now, I wonder if I've repeated the same mistake twice. That's almost inevitable here. I'm definitely thinking about how this works, and I'm using the same things I did 5 years ago when I did this Rust version. Oh, for the camera, 1.8. There are many values here. I don't know what one is 1.8. Oh, you mean the direction? It could be an artifact. Let me just bottom that out for you, if I can remember the right one. So let me zoom in. Yeah, the camera here is the same. I think this is what you were meaning. It is 1.0. It is my funny font that I've got in my tonal. It probably makes it look more like an 8. So thank you for checking on that. But I'm wondering if I've got the same problem that I had with the Rust code that I fixed by changing like the size of the diffuse, of the light. So the light was always a light, something you could actually see in my code before. So I'm wondering if I just repeated a mistake, as I say. Let's see if my back wall is different in the two cases as well, because if so, then I've just done something wrong twice over. So we've got left and right. We've got what I have commented as back here and 50, 40.8, 1E5. See, that looks about okay. We've got the front wall, which is black and black, and then it's 1E5, 50, 40.8, 1E5 plus 170. No, so the code agrees on what the front and the back is, and here I'm using the color to tell me whether something is the front or the back. And then my two spheres here are not visible. This light is giant, so I'm going to, for now, duplicate that, leave the old one, and I'm going to copy in the Rust version, which has a 1.5 meter camera at, and it looks like I've taken 6 off of that to make it 81.6 minus 16.5. Apparently that's a load of made up numbers if ever I saw it. 81.6, and then I've made it 400. So one thing, by making the light smaller, it means it's far less likely that a ray is ever going to hit it. So I wonder if we're actually in the inside of the spheres rather than the outsides of the spheres. I think that's probably what's happening here, isn't it? I wonder if then the sampling is the wrong way around. Okay, wow. A lot of this comes down to the fact that I really should have thought about this a bit more. So what have we done here? We've just moved the light to be a different place. Yeah, and now it's tiny. If I make this 400, does that work? We also have to recall that I was starting to do light tracing with the Rust version. Yeah, okay, that doesn't work at all. Well, I might have to draw this out, which is unfortunate. So 681 minus 0.27 and 81.6, so XYZ. So it's a little bit into the room. Let's remind ourselves where the camera is. The camera is at 50x. Where's a pen and paper when you need it? Loads of notes here from contracts and things. We have a camera at 50, 52, 295.6. So I'm going to draw here 50 in the X. That's weird. 52 up and 295 in the Z. And it's looking backwards. Okay, I think I see that. I don't think I realize fully that the camera is like at the scene looking, in what I think of as my view, towards me. Now I wonder if that's the root of the confusion here, that I have somewhere I've got a left-handed, right-handed thing the wrong way around, like has been suggested by some of you fine people. Okay, and then we have a sphere who is at infinity plus 1 x 40 and 81 y and z. And it's of infinity 1e5. So that means a 1 meter, I think. And then the other one is at minus 1e5 plus 99. Yeah, these are the inside walls of the spheres, aren't they? That's what I think we're seeing here. These are the inside walls. That doesn't really affect much, but we can go and have a look at it in a second. I don't think I account for whether I'm in the inside or the outside. So one of these many things on the right hand side in this radiance nonsense is getting these spheres. Yeah, x minus obj.p.norm. This n is the normal. And there it is. There's a magical thing that's turning the ray around so that it either reflects, if it's in the inside, it reflects inwards, and if it's on the outside, it reflects outwards. I think. Now, do we use N or NL everywhere? Search for NL. Search for N. Do we use N after that? Let's do that. Where does it highlight? It's used down here. So we get the true normal down when we're using specular. But everything else is using the normal facing the way towards the intersection point. Like towards the ray that hit the intersection point. So that's part of the problem, I think, here. I don't know that I'm doing that. Let's go and have a look. Inside my sphere. So this might actually be something we can write a test for. No, sphere.h. And the normal is just the hit position minus center dot normalized. There we go. So that's definitely something that is not the same in both cases. So we currently, so I've got a terrible picture here of what's going on, but when we intersect with a sphere, I wonder if I can get something better up here. Let's get something that I can draw in, however dreadfully. File, new, sure. Yes, that looks great. That'll do. Is this working? No, give me something a bit more brushy. Yeah, okay, not pixel. You can tell that I mostly do pixel artwork whenever I do anything at all. Yay, that'll do. So we've got a sphere, and we have just taken a ray and we've intersected it, and we found the nearest of the two intersection points here. So then, having found that point, the ray's intersected with this point, we want to know what is the normal at that point on the sphere. And the normal, there's the center, is we take a ray, or rather a line from the center of the sphere to the intersection point, and that is our normal. And therefore, when we are looking to scatter light away from it, and I should probably use a slightly less fat brush for this. Oh, come on. Showing off my lack of ability, not spacing, that's not what I want. Where's my brush size? There it is. So when we're scattering light off in all these directions here, we're actually scattering about the normal of the surface. And that's great, provided that you were on the outside of the sphere looking in. What we're in is actually here. We're inside the sphere, because what we're seeing is that this wall here, that curve there is the inside of the wall. And I've drawn that badly. But we're casting rays, I should pick these colours. We're casting rays outwards, hitting the inside of the sphere, which is acting as our wall. But then, of course, further rays that we cast will be sent off outside the sphere, and therefore are probably just hitting that light all the time. Because the light is this giant bright thing that takes up most of the space, but is outside of the box that we're in. That's the worst explanation ever. But let's run some tests. Let's write some tests. And I have got myself, how much longer? 15 minutes to try and at least get something working. But we still don't understand the inside versus the outside of the back wall thing. So we've definitely got something else inside out. It's not just that. So let's use math tests. Let's run the math tests. And we'll just go and bring up the sphere tests. And intersection with sphere at known intersection point, we're going to take one of these and we're going to take from the inside. So intersection with from within sphere at node intersection point. So we've got a ray that intersects currently at point from 2 points. We've got a sphere at 0, 0, 30, and its unit is 10 long, and we're firing a ray directly at it from the origin towards it. And what I'm going to do now is instead I'm going to be from the actual center of the sphere, so it's unambiguous, and we're going to go backwards. Well, actually that's fine because it's pointing that direction. We should hit the same point, but the normal should be facing back towards us. Right? The normal, if you're inside the sphere looking out, and you hit the inside of the sphere from within the inside, then the normal should be facing towards you. It's not really strictly true, but that's what... Actually, I wonder if that should that be part of the sphere intersection? Yeah, Andreas has said this, you know... Yeah, this I'm wondering... So from a pure mathematical point of view, this is not really part of the sphere, is it? Or is it? I'm sort of debating now whether or not this is something that should be fixed up inside the radiance function itself to bend the light towards or the sphere. Now I'm going to define it to be in the sphere for now, and we'll kind of come back and think about that. So then we've got hit position right along. There's the normal, and then what we're going to say is if normal dot ray dot direction is less than 0, normal equals normal times -1. And that should fix our test. Our test will still fail because one of the distances was still wrong. Thank you, Luca. I really appreciate you hanging around and chatting. And, oh, we've broken some other things. Oh, inadvertent. Due to a fatal error condition, segmentation violation signal. That was not what I was expecting. That's absolutely not what I was expecting. Well, isn't that a doozy? Let's go and work out what's going on there. So let's run it under the debugger. Why do we want to be inside the sphere again? This is just how small points set of walls are set up. They are not the outside of spheres, they're the inside of spheres, unless I'm missing something, Andreas. You may have been able to follow ahead better than me, but I just want to get this working the same way as small point does. Okay, we've got crashing in approx vec 3 in apparently operator streaming operator. Oh, look at that. This is the first time I've tried to print an approx vec 3 and see if you can spot the problem here. I think the key here is the stack that is forever. So we're streaming ourselves out by saying, hey, yeah, stream ourselves out. That's not going to work. Whoops. v.vec is what we were meant to do there. Okay, now we're cooking with gas. So everything seems to have broken, which is maybe right. Maybe. I'm not in love with this right now. We've got normal equals 0.01. Oh, we've got -0. Thank you, floating point arithmetic, for being so dreadful. So let's just replace all these with approx vecs, because that's what they really should be. All right, and oh, well, isn't that interesting? Okay, this is x minus object.p, and it's if less than 0, then n, else n minus 1. I've got that the wrong way around. So again, just test everything. I'm so lazy about testing, and I should not be there. It's always the case. You find something, and you know, I could have run the render and it would have taken ages and we would have found something else, but at least I knew what I was trying to achieve in this instance, and I didn't, and I'm glad I wrote a test for it. So what are we looking for? We're looking for intersect inside sphere.h. And here I said, hey, if it's less than 0, then it's -1. No, if it's greater than 0, then if the ray direction is hitting the back of the sphere, and so therefore we're like trying to look along the way that the sphere is going, then we actually want to see the back, the normal coming the other way. The normal should always come towards the ray direction, is what that's saying. And now the distance should be wrong, for the right reason. Yes, 10 is equal to 20. That is right. Okay. Well, my friends, this is a lot of grind for not as much joy as I was hoping. Okay, so the tests are now passing. Let's go back to release mode and let's go back to PT3 ways and just see what we get if we run the code with a now fixed sphere implementation, and see if we can somehow square our understanding of what we're seeing with that. My suspicion is it will suddenly go very, very dark, because I don't think we'll be seeing any real intersections with the light anymore. Oh, I hate it when I'm right. So my theory about what was happening before is that we were firing rays into the inside of spheres. We were then looking outside of those spheres for diffuse interactions, and because we weren't looking for... because we then actually fired out diffuse rays, further rays, further outwards, we'd eventually hit the inside of one of the emissive spheres, because it's giant and huge and represents a lot of the space. But now we're not hitting anything at all. So we've gone from greatness to sadness. Let's just remind ourselves what we've got going on over here inside these things. Oh, it's so sad. All right. What I think I'm going to do right now is start with the simple case of, let's just return up here, return mat.diffuse, which I need to do here, and then we need to get rid of all of this stuff here. So we're writing the world's naffest one bounce or naught bounce ray tracer now. Oh, you would complain about those, wouldn't you? So I know we just fixed the normal thing, but now I'm back to kind of like, well, what should we be seeing here? Oh, go away. Not that. Yeah, so here we're now seeing the just purely the first bounce hit of everything. We seem to be looking up rather than down, which I know that there is a camera flip somewhere else. I am going to now move the left hand. I'm going to reduce the radius of the left red wall and see if it goes away from us towards the left or goes towards us to the right, to sort of prove to myself whether this really is the inside or the outside that we're looking at. So that left wall is 1e5, and I'm going to do 1e5 minus 1. Alright, I'm going to move this and put this back on always on top. And we're going to run here. And I'm just going to stare at the screen. Oh, I didn't notice it change. Let's try 10. Of course, we render super quickly now, because we're not doing any bouncing. Bounce. Okay, so as we're making the left-hand sphere smaller, we're seeing it come in, which is just proving to me that we are actually looking at the inside of the spheres now. I know I've drawn it out here and I've proven it to myself there, but it's just nice to get some indication that I'm not totally off base there. So that's the left one going left, and if I were to do minus 10 on here, we would see the right one come to the left. So we should now see the blue thing come over to the left-hand side. Right. So now we're back to how we were before. I'm interested about this top one because I think we're looking at the view upside down. So if we were to remove the top one and the bottom one disappears, then we'll be in sort of some sense for me. But I've got a feeling it is going to remain. Okay, that's good. So I think I understand that. So I am going to change that to make it by where do we get the camera? We get for the camera is YY. Cam Y is that normalized. So I think we've got like a left-handed versus a right-handed coordinate system. So maybe my cross product is just not the correct way around. And I forget how that works. But if I put a minus sign in here, I can't actually do that. But I'm going to do times -1 to do question mark. Is this going to like, this should now turn the scene the other way up. Okay. Now the top is the top, but it's almost like the Z is the wrong way around as well. But we know that can't be the case. See, there's a difference between like drawing the scene in a particular way and just saying like, well, we're numbering Y from the bottom and going up. So I can get rid of that. That's what we're doing with the other thing. Is like this is actually like height minus Y -1 is what we do in the Rust version. So we should end up with the same picture there. We're missing the top. How are the front and back the wrong way round? That is just perplexing me. And why can't I see the other spheres? Whoops. Let's comment back in the top. This light, let's for now give it an actual appearance. So I'm going to make it bright green or something. So red, green, 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 blue. Because I want to see where that light is, if it's anywhere in the scene that we can see. So the light is apparently at the top, like we would imagine it is. Oh, no, wait, sorry. That light there is not actually visible that I can see. So let's get rid of the left, the right, the top, the bottom, and run with just the light and see if the light even turns up anywhere. We're looking for a green blob somewhere in here. Oh! Isn't that interesting? Isn't that interesting? I wonder if there's just a problem with my distance stuff. So now we can see that there is definitely a big fat light at what is apparently the top. It's hard to tell exactly what it looks like, but let's... I wonder if my distance is wrong. You know how I've got that loop where I find the nearest point by checking if the distance is less than anything else? I bet you that's broken. Oh, see, that looks... I'm beyond bewildered by that. So the scene without the top looks like that. The scene with the top... Oh, of course, because, again, we're looking at the inside of the sphere here. So what we're looking at the inside of the sphere here is that green circle is the tiny part of the giant green circle that's above us, poking through the otherwise inside of the sphere that we're seeing. So that top is, if you think about it, like this, an infinite sphere over the top that goes over forevermore. It's like having your head at the top of a bubble. That makes some level of sense. But we can see that our two other spheres are in fact now visible. Here and here. Let's start adding in things and see if we can work out what's going on. So we'll put the bottom in, which is another like giant sphere. that should be above us, right? Interesting, that didn't actually make any difference. Oh, it's also grey, that's why. Let's put the left sphere in. And your right sphere in. Can't believe that apparently there are 50 odd people listening to me fail to debug a simple scene here. Alright, so now that's hard for me to picture what the heck is going on here. So we can see there's an infinite sphere, or no, a very large sphere that we have the inside of on our left hand side, which is red, and one on the right hand side that's blue. And the fact that they're overlapping in weird ways, I'm still deeply suspicious of that distance check. So I'm going to go and have a look at it. It's just my spider sense tingling on that. I can't tell you that I have some deep insight as to why that is the case. But let's go back to our sphere test. And we have this distance, and the distance here comes from plus t minus t. So position along the ray. So as long as that ray is normalized, that hit position should be in regular units. Let's go and compare this to what small point does. Okay, spheres don't intersect. Oh golly. And this just returns t is b minus det. This is very hard to reason about with these giant spheres being like the wrong way round as far as my brain wants to talk about them. I just can't picture it properly. So position along t, and we either pick minus t or plus t here, which is me doing this thing here, which is b minus det or b plus det. And we say if that, and we've got this epsilon of 1e minus 4, which is some random ass number that, excuse my French, that we're testing against. So if the minus t is greater than epsilon, then we return minus t. This is horrific. Thank you, Michael. That's probably right. It's 4 huge spheres intersecting in one point on the horizon. They all have the same radius and are placed symmetrically left, right, top, bottom. Yeah, that I think is what I think you're right there. I'm having difficulty like developing an intuition to move on from there, to try and work out why apparently the front and the back are the wrong way around. But the thing about the front and the back, so I suppose that now I'm trying to think about it and out loud. I can't see where my maths is wrong, which doesn't mean to say it isn't wrong. But the fact that the front and the back seem to be fighting each other, to me feels like I'm firing a ray and I'm hitting one of the two. I'm hitting like the wrong face of one of the spheres and it's obstructing it. No, that doesn't make sense. I don't know. This just seems to be right. What I'm seeing here looks right to me. It's either that or 0, and if they're both less than epsilon, which is the reverse of this, give or take an equals, which I think is fine here given the epsilon is like so huge, then we don't hit anything. Otherwise we're going to say one or the other, and I just think that seems right. Okay, I'm going to claim that that's all right, and rather sadly come back to this. Let's bring back our friend over here and try and remind ourselves what we've learned so far. So is that back sphere, or the front sphere, sorry, is this the thing that's obscuring all of the other spheres behind it now? Because we know the back and the front are the wrong way around. In whatever coordinate system we're in. Yes. Okay. So somehow, what happens if your camera is actually sitting on a sphere? That is a good question. I don't I don't know. I think that's what that epsilon is about for some excuse me, extent. Is like, do we graze the edge of the sphere? So here what we're seeing is top, bottom, left and right are correct. We have got a back wall. Yeah, I don't think the camera is exactly on a sphere, but let's have a look. It is at 50, 52. And 50, 52 doesn't like immediately and obviously jump out as something that would be on a sphere. It's hard to know though. The camera is outside the box, yeah, outside the back wall. But if it was outside the back wall completely, yeah, that's interesting, isn't it? Yeah, you're right. It's outside the back wall. What if I were to move the camera forward? Let's just play with the camera position. And okay, so it's pointing the other way than the way that I would otherwise think it would be. Let's play with moving it down. Sorry, whatever that number was. Was that 52? 42. 52. Let's try moving it 100 units in Z and see what we see. Because we can, right? This is the kind of world we're in right now. Is the crazy debugging world of, okay, now we see nothing. Okay, split the difference. So let's do 255. Okay, so we're moving towards what should be I think is the front wall. But we know that at least by the comments, the black thing that we're now looking at is, I think, meant to be the back wall. It's the black one. So 295, which is what it was before. Well, that's interesting because the direction of the camera is apparently such that increasing Z is in the negative Z space. So as we decrease, that makes sense, right? As we decrease Z, we are moving forwards in the image towards that black wall. So if I were to now make this 275, we should see that black wall get bigger. Right. But if I move it too much further, we just go outside of that and we don't see anything anymore. Like, for example, if I make this 200, like we were saying before, we're going to go out the back wall. And now we get a black picture completely. So there's something very, very, very fishy going on here, because you'd think those being so giant spheres that we would see something. But are they all behind me? Right, let's just sort of try and find the point at which we hit the back wall and then go out the other side of it and then discover we see nothing, or we just see back wall forever. Yeah, because, you know, like, I'm thinking, hey, as soon as we clip through that black wall, we're going to see our lovely objects. But, you know, we're not getting there. Where are our objects? They're at like the origin. One of these two chaps is right at the origin. So as we're moving this way, I mean, what if I, instead of using this direction here, I'm going to say auto camder equals vec minus campos normalized vec3. So we're just going to always look at the origin here. But actually, no, we're going to look at the center of one of the two spheres. 27, 16.5, 47 minus campos dot normalized. Right? So we're going to be pointing directly towards the center of one of those two objects. All right, and now we're going to clip through and do 205 and hope that this is enough to get us through, but we're going to keep going until we see the damn thing. Excuse my French. Hello, cat. So now I don't know what we're seeing. Let's keep on going. 155. Woo! Well, isn't that odd? Why? Your instinct was absolutely right, Michael. Well done. But I am confused as a confused thing. Did I get the camera position wrong when I start it from small point? Let's have a look. The camera position in small point is 50, 52, 295.6. What else could be going on here? Is there something? Oh, look. Oh, what does this say? Camera rays are pushed forward to start in interior. Table flip. So they're in a bit of code that none of us have looked at. The camera rays are pushed forward apparently by 140 units in the direction of D. Oh, I'll just type all sorts of magic numbers in there. So I think we've discovered what is going on here. Cam.O plus D times 140. What the heck is D? D is the direction towards the normal. See, I do my camera slightly different from the way small point does it. Cam.O plus D times 140. Ugh. So it's 100. They essentially have the plane of the camera 140 units ahead. Well, shucks. And we've basically worked that one out, right? 295, 155. We couldn't really have done a better job of coming up with those numbers. So what happens if we use the original vector here? I don't think this is still going to be quite the right scene. Are you ready? Oh, I've seen it. I've seen it in the preview window. Look! We're almost there. It's almost the same. Now, I think the difference in the view is now more down to the sort of the angle of the camera and things like that, because it's obviously moving out and starting its rays 140 units away from the camera, which we haven't done. But I could do the same thing. I don't like it though. I much prefer projecting forward. I guess that's something I can do. All right, I think I'm spent for today. You have all been amazing. I've had such a good time. Actually, why don't I'm terrible for this, aren't I? NB to do small put forces raise forward by 140. Okay, I'm gonna get rid of those because I don't think we need our old scene anymore, as lovely as it was. I don't like to have bits of code knocking around that aren't actually useful. I think we have a valuable test mode here, right? I will leave that there for now. Let's comment this back in. We only have diffuse materials. We want to... Got all of those things. What was the other things we needed to undo to get this to work? Okay, we probably need more than 10 rays. Let's go for 100 to start with. Somebody made a suggestion, an excellent suggestion of giving progress, so I think we should probably do that. So let's do static cast double of y over a height times 100 if y and 7 equals 0, something crappy like that. Percent, thank you, IDE. And we get some kind of feedback about how far through the process we are. I'm sure there's... Oh yeah, I know, it's this horrible green colour that we've given the light. Where is the light? 12, 12, 12, 0, 0, 0. This just needs to be that. And we're going to rerun that. Oh, please let it work. Oh, that's a lot slower, isn't it? Well, that's not true. I don't know why we're not seeing any percentage coming out here. Because this ought to have printed at lines. Oh, there we get it at the end. Oh, joy! Joy to the world, everybody. We have what is a not totally dreadful rendition of the Cornell box without all of the other material things, which is definitely something else for me to look into another time. But right now I am Hank Marvin. I'm starving and I need to go and spend a bit of time not talking to myself in a room with only my cats for company. And your good selves, obviously. So this has been a journey. This has been really good. And we've obviously learned a whole bunch of things here. I don't think I would have gotten here quite so quickly without Michael's input and some of the other fine people. Next steps. So I will do another one of these. And I would like to probably spend a bit of time away tidying up some of the codes. Some of the things that we've discussed that aren't particularly good. I think obviously we need to implement material. I'd like to actually implement different surfaces, not just spheres, and then half of this problem will go away because I would use a bloody box for a box and not infinite size spheres. Thank you, Andreas, for the feedback. I really appreciate it. I do wonder, we've been talking now for 3¼ hours. Oh, thank you, Noxabellus. Yeah, it's difficult to know whether or not I'm giving the right amount of information and feedback, whether I'm just talking to myself, whether I'm going too quickly, whether I need to explain more things. So I appreciate all the feedback that I get in the chat, and I do read it all, or try to read it all while I'm going. This is very sort of apropos of nothing exposition of the way that I program. I know many people program in different ways, so it's been fun, and we'll do it again. I'll tidy it up. The code is on GitHub. You'll find it PT3 Ways, I think it's called, on my Matt Godbolt GitHub. Wherever that's hiding. No, I appreciate all of your feedback, and it's been a lot of fun. I'll do it again sometime next week, or maybe even later this week. Just check my Twitter stream, or if you really want to keep up with this, the obvious like and subscribe nonsense, please do that. And then if you subscribe and hit the alarm bell thing, then you'll get a notification when I go live, which will give you a bit more instant ability to join in with me. So thank you, everybody. It's been an absolute blast. I will see you the next time. Bye for now.